Hello there and welcome back to the Sleep Science-y. Tonight you're drifting in through the static hum of a European Space Agency livestream, the one half the world forgot was even running. Somewhere out there, roughly 400 million kilometers beyond Mars, a faint speck slides across the darkness. The telemetry tag reads 3I Atlas, only the third confirmed interstellar object ever caught visiting our solar system. You lean closer to the blue glow of your screen. Pixels flicker, data bars crawl, and for a moment you could swear the comet pauses to look back. You probably won't survive this, not because a comet will hit Earth, but because curiosity is an appetite that never stops eating its host. Every new discovery devours the certainty that came before it. Still, you can't look away, so before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. Tell me where you're watching from tonight. City, country, maybe even your local times, and now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. The ESA feed begins in perfect bureaucratic calm, muted voices scrolling telemetry, a commentator repeating phrases like nominal and within expectations. You sip your tea, lukewarm, always, and try to decipher the numbers. Atlas, named after the Hawaiian telescope array that first spotted it, isn't behaving like a typical comet. Instead of an elongated ellipse, its path cuts a hyperbolic slash through the solar system, a shape that means one thing: this object came from somewhere else and will never return. You picture it, a chunk of frozen time, wandering between stars for perhaps millions of years before gravity nudged it toward us. It doesn't belong here any more than a snowflake belongs in a volcano. And yet here it is, shimmering faintly against ESA's digital backdrop. For a moment the camera zooms too close and the image stutters. A thin bar of static ripples downward, then another. The feed freezes at a frame where the comet's tail seems to bend twice, like a ribbon caught in wind that doesn't exist. When it unfreezes, mission control carries on as if nothing happened. You chuckle softly. Space glitches are practically tradition now. Remember that time NASA's livestream caught a moving dot near the ISS, and the internet decided it was aliens for a month? Some traditions never fade. Still, something about the pause bothers you. You scrub back a few seconds, replay it. Same bend, same stutter, same perfect resumption. You file it away under possible compression error, but your brain writes a second label underneath. Or maybe not. Atlas is the sequel no one expected. The first interstellar visitor, 1I Oumuamua, arrived in 2017. Cigar-shaped, tumbling, suspiciously shiny. You remember the headlines, the Harvard debates. The polite but frantic reanalysis of orbital data. Back then, scientists argued over whether it was a rock, a shard of a shattered planet, or a lost sail from an alien probe. Historians still argue whether Oumuamua was the moment astronomy finally allowed itself to flirt with science fiction. Now, just a few years later, here comes 3I Atlas, striding in like a younger sibling demanding equal attention. Only this one has a visible coma, the hazy cloud of gas that makes a comet look like a comet. The ESA commentary explains that its brightness fluctuates irregularly, hinting at jetting, gas eruption that spin it unpredictably. The voice sounds calm, but you sense a quiver underneath. The math doesn't fit. You jot notes in your worn notebook, the one already full of cosmic gossip: rotation unstable, coma asymmetrical, tail bends twice. You underline that last bit twice. Outside your window, night presses against the glass. A siren wails somewhere distant, blending with the white noise of the fan you left on purpose. You glance back at the screen. ESA's logo glows steady blue. The host smiles as if nothing monumental is happening, but you know better, because even through pixels, even through the static tour, you feel that ancient thrill, the realization that something not from here is briefly passing through here. The same all sailors must have felt spotting a drifting iceberg in tropical waters, proof that the map had failed again. ESA's next data packet arrives, showing spectrum lines, chemical fingerprints, carbon monoxide, carbon dioxide, traces of ammonia ice, all standard comet fare, but with odd intensity ratios. You know enough chemistry to sense what that means. 3I Atlas formed around a star richer in heavy elements than our sun. It's alien dust, literally. You imagine a system with two suns, or a dying red giant shedding outer layers, and some small fragment freezing mid-storm before being hurled into interstellar exile. There's a quiet beauty in that exile. You imagine the comet drifting for eons through the void, cold beyond comprehension, occasionally brushed by the distant starlight that could never melt it, until by chance it fell into the mathematical net of our solar gravity, where human cameras, tiny impatient, finally found it. ESA switches to infrared imaging. The comet flares like a ghost ember. Then, another glitch. This time the feed cuts entirely. For 2 seconds, nothing, then a placeholder graphic. Signal temporarily lost. Chat windows explode with comments. They cut it, cover up, just a relay switch, relax. You smile at the chaos. Humans are predictable. Give us a mystery and we'll light it on fire. When the signal returns, the image is slightly darker. The tail appears shorter, the core brighter. Someone in mission control mutters about recalibrating exposure. You take a screenshot before the next data wipe can occur. Here's your first joke of the night. ESA's software apparently believes that if it can't explain something, it should just lower the brightness until it disappears. You muse that most people run their lives that way. Minutes stretch. You watch light curves rise and fall. Listen to the mission clock tick. Feel the hypnotic rhythm of numbers. The feed commentator slips in a historical anecdote. In 1680, Isaac Newton studied the Great Comet to test his new law of gravitation. You imagine Newton hunched by candlelight, squinting through crude glass lenses, convinced he could read divine geometry in the sky. Back to the present. Your modern instruments are better, your understanding deeper, yet mystery persists. Historians still argue whether Newton's obsession with comets pushed him closer to science or to alchemy. Maybe both. You can't help but respect that kind of intellectual double life. ESA's translator channel mentions the comet's estimated speed, over 60 kilometers per second. That's fast enough to cross Earth's diameter in 2 minutes flat. You imagine riding it, hair, and probably entire body, shredded by plasma winds. You grin. Every childhood dream of space travel ends in something like that. Another odd data point arrives. Thermal readings suggest a hot spot near one pole. Not melting hot, just warmer, about 10 Kelvin above average. Some models blame solar heating, others whisper internal radioactivity. You tilt your head, wondering, could an interstellar object really carry radioactive decay heat after millions of years? Historians, well, scientists this time, still argue whether that's even plausible. You jot another note, possible nucleus fragment activity. It sounds clinical, but what you really mean is, it's alive in its own way. The ESA commentator begins listing the instruments on board: photometers, spectrometers, dust analyzers. You notice how casually they skip over data irregularities. Maybe they're still processing. Maybe they're waiting for an official green light before admitting anything odd. Bureaucracy travels slower than light. You stretch, rubbing your eyes. The fan hum merges with the subtle hiss of background cosmic microwave radiation playing through your imagination. Everything feels half dream. You're half tempted to believe the comet isn't real at all, that it's just a projection of every unanswered question humanity has about the universe. Then suddenly, the feed brightens again. The comet's image sharpens. Tail glowing with a thin blue edge. A technician's voice, unmuted by accident, murmurs, "That colour shouldn't be there." The line cuts out immediately after. You blink, rewind, replay. Yes, there it was. An accidental truth escaping live. Blue-green tails can mean diatomic carbon emission, common in many comets, but the shade you saw was closer to turquoise neon, an impossible colour in vacuum conditions at that temperature. You grin again. Cosmic irony tastes like caffeine. You glance at your notes. Underline, that colour shouldn't be there. Outside, the world continues. Traffic lights, barking dogs, restless cities. But inside this small pool of screen light, you're suspended between two galaxies, the one you were born to and the one the comet came from. ESA's commentary fades into background static as they switch to pre-recorded filler. You sit back, breathing slowly, realizing you've just witnessed something that might rewrite a textbook, or at least dent one. The comet is still out there, streaking silently through blackness, carrying a secret in its tail. And you're just another night owl scientist, half amused, half bewitched, clutching a screenshot that may or may not mean anything. You save it anyway. The folder name reads for later, because there's always a later, even if later means years of wondering whether you actually saw what you thought you saw. The screen dims automatically. You let it. The fan keeps its gentle monotone. Somewhere in the void, 3i Atlas continues its patient descent toward the inner system, as if drawn by curiosity itself. You whisper into the quiet, "Welcome to the neighborhood," and though no one hears you, the words feel necessary, like greeting a traveler before they vanish again beyond memory. You wake to the faint blue glow of your monitor still burning through the dark, numbers trickling down the ESA feed like rain on glass. You never really slept, just drifted somewhere between dream and telemetry. The comet is still there, now brighter, sharper, more insistent. Its name, 3i Atlas, feels heavier this morning, the way names always do after they've crossed from speculation to data. Somewhere deep inside that stream of ones and zeros, your mind is already chewing on a single question: what makes it interstellar? You reach for your notebook again, flipping past last night's messy sketches and underlined guesses. You write the word escape, because that's what defines it: escape velocity not from a planet, but from an entire star. Every comet you've ever studied until now lived comfortably within the sun's dominion, swinging out and back like loyal satellites. But Atlas? Its orbit isn't closed, its trajectory doesn't loop home, the numbers spell freedom. ESA's morning briefing begins with the usual sterile calm. A scientist with the voice of a yoga instructor explains the hyperbolic excess velocity, 30 kilometers per second faster than anything bound to our sun. She adds that this mathematically proves it came from beyond the solar system. You pause the stream. Mathematically proves. You mouth the words slowly, tasting the confidence like synthetic sweetener. It sounds satisfying, but something about the phrase feels off, because math doesn't prove, describes. The proof lies in interpretation, and interpretation, as history shows, is always messy. Remember when astronomers in the 1800s were convinced there were canals on Mars? The math describing them was perfect: angles, proportions, even seasonal changes, and yet the canals existed only in human imagination. Historians still argue whether that was the first collective hallucination of modern science, or simply the product of telescopes too eager to believe. You lean back and watch the simulated trajectory, a graceful curve slicing through our solar system like a thrown blade. The program colours it in a luminous white trail, a gesture of artistic optimism. But you know it's invisible out there, a lump of dark ice swallowing sunlight. What fascinates you most isn't that it's here, it's that it ever escaped. The gravitational prison of a star is no small thing. For an object to be launched free, something cataclysmic had to happen. You picture it, maybe a planetary collision, two worlds scraping together in a burst of molten debris, or a dying sun coughing in its last expansion phase, spitting icy fragments into interstellar night. Atlas could be the shrapnel of apocalypse, a frozen echo of some system's final moment. You imagine alien astronomers, if they existed, watching the same object eons ago as it left their sky, whispering their own version of goodbye. ESA's graphs scroll again, and your eyes lock on the eccentricity value, 124. Anything greater than 1 means it's not bound by solar gravity. 124 is almost excessive, like it's overcompensating. You smile. If comets had personalities, this one would be the overdramatic sibling that storms out of the family home and never calls back. Your inner voice of caution chimes in. Be careful romanticizing data. You try to laugh it off. Still, it's hard not to feel a pulse beneath the numbers, a faint rhythm of rebellion. In the chat room beside the feed, amateurs and astrophysicists type furiously. Someone named Deep Space Diva asked if the comet could just be a rogue from the Oort cloud, flung outward and returning. Another user, Data Drip, counters that the approach velocity is far too high. They argue in tidy paragraphs, both partially right and both deeply certain. You grin. The internet's finest pastime is certainty and the absence of evidence. One post catches your eye. If it's truly interstellar, then it's older than any fossil on Earth. That sentence sits on the screen like a dare. You whisper it aloud. Older than any fossil. That means older than our continents, older than our oceans, maybe older than the molecules that became you. It's like holding a time capsule from before time was measured. A few hours later, the ESA press release drops. 3i Atlas confirmed as interstellar object. They include orbital diagrams, data tables, and a sentence that makes your pulse skip. Composition appears consistent with exoplanetary debris. You read it twice. Exoplanetary debris. That's bureaucratic poetry for From Another World. Still, skepticism whispers louder than wonder. You scroll to the footnotes, margin of error, approximated uncertainties, assumptions of isotropic distribution. The fine print is where humility hides. You think of another historical moment, 1919, when Arthur Eddington measured the bending of starlight during a solar eclipse. It proved Einstein's theory of general relativity, though the data were messy and the methods primitive. Historians still argue whether Eddington's results were solid evidence or just wishful interpretation packaged for headlines. Science, you remind yourself, often begins with belief waiting for confirmation. So yes, mathematically, Atlas is interstellar. But emotionally, you're not convinced yet. Not until every spectrometer, every telescope, and every over-caffeinated grad student agrees. You sip your coffee, too bitter this time, and switch to the infrared composite. The comet's coma glows faintly, like breath on cold glass. Somewhere in that haze, sunlight is releasing molecules that haven't seen warmth in millions of years. The idea makes your skin prickle. What if inside those grains lies chemistry we've never catalogued? Amino chains built in alien conditions? You chuckle quietly. If there's alien DNA in there, ESA will rename it paperwork. Your fan gives a soft metallic click as if agreeing. A sidebar headline flashes. Atlas outgassing irregularities suggest non-gravitational forces. That phrase, non-gravitational, makes you sit straighter. It means something besides gravity is pushing it. Maybe jets of gas, maybe something stranger. You've heard that before, back in 2017, when Oumuamua's odd acceleration birthed the light sail hypothesis. You grin at the memory of respectable scientists using words like propulsion and intelligence on live television while pretending they didn't enjoy it. This time, though, the ESA team is cautious. They call it sporadic jet asymmetry, which is scientific code for "we don't really know." You write it down, because "we don't really know" is your favourite sentence in the language. It's the heart of discovery, dressed in humility. Hours pass. The comet inches closer to the inner solar system. ESA's animation shows its incoming path slicing through the plane of planets, a brief intersection of cosmic traffic. You imagine how small Earth looks from its perspective, a pebble orbiting a yellow campfire. A soft chime alerts you to a new telemetry drop. The data looks fine, until you notice a timestamp discrepancy. 2 minutes missing. You scroll back, check again. The gap remains, a tiny blip in time swallowed by some process no one will admit happened. You frown, half curious, half amused. Computers forget things all the time. Humans just call it maintenance. Your third joke of the night bubbles up. If 3i Atlas were a person, ESA would have already muted its social media accounts. You jot another line. Interstellar means unpredictable. Because once you escape one star's gravity, maybe you stop playing by anyone's rules. In a quiet moment between data packets, you lean closer to the screen. The comet's trajectory renders in slow motion, an elegant arc of defiance. And then, for no reason at all, you think of migration. Birds crossing oceans, guided by forces they barely perceive. Maybe interstellar comets are just cosmic migrants, driven by instincts written in gravity and chaos. A fragment of poetry floats into your mind from somewhere. Not lost, only far from home. You smile. Back on the feed, an ESA analyst begins to speculate about origin points. Perhaps ejected from a binary system, she says. Or from the outer debris ring of a young star in Lyra. Her tone carries the wonder of a bedtime story. Binary systems, twin suns locked in endless dance. You picture Atlas slingshotting through that firelight long ago, its surface melting and freezing, carrying traces of two stellar chemistries mixed together like cosmic marble. Historians, future ones maybe, will argue about how we classified such visitors. Were they comets, asteroids, or something in between? The boundaries blur every time one of these wanderers appears. What makes something a comet anyway? Tail? Ice? A poetic temperament? Science will keep updating its definitions until the mystery politely agrees to fit inside them. You stretch, shoulders cracking, and glance at the clock. Outside, dawn stains your window pale gold. Inside, your screen still hums with deep space data. You realise you've spent the whole night watching a snowball from another star pass by your cosmic doorstep. There's something both humbling and hilarious about that. somewhere behind the official reports, behind the mathematics and jargon, lies a quieter truth. The label interstellar isn't just a category, it's a confession. It says, we've found something we didn't expect and we can't explain it fully yet, and somehow that's enough for you. The notification chime hits like a caffeine jolt through static. The European Space Agency has just dropped its long-promised 3i Atlas photo bundle. You're halfway through reheating yesterday's coffee, which already tastes like compressed despair, when the images start downloading. The thumbnails bloom one after another across your screen. Iridescent tails, carbon black nuclei, stars like frost in the backdrop. You catch yourself smiling. For a second it feels like magic, proof that somewhere beyond imagination, this alien visitor is really there, photogenic and punctual. You open the first file. At first glance it's perfect, composition straight out of a sci-fi movie poster. The nucleus glows faintly, a shimmering heart wrapped in vapor. But your eyes, trained by too many late nights and too many doctored UFO JPEGs, immediately twitch toward the corners. Something's off. The star field behind the comet repeats, pixel for pixel, pixel, every few centimeters. Copy-pasted stars. That's not space. That's Photoshop's idea of infinity. You mutter, "Oh, ESA, don't you dare." Maybe it's just an artifact from image stitching, you tell yourself. Still, curiosity starts gnawing faster than caffeine ever could. You drag the photo into your editing software, magnify it to 800%. The comet's edges blur unevenly, the tail cut short by a faint rectangular outline. It's as if someone masked it, softly, carefully, but not perfectly. You check the metadata next. File creation timestamp, 3 hours before the public release window. Then another oddity, an embedded note in French, ajusté pour contraste visuel. Adjusted for visual contrast. That could mean anything from colour balancing to creative rewriting of physics. You chuckle. Bureaucratic poetry always finds its way into scientific art. The second image loads, this time a wide-angle shot from ESA's ground-based observatory in Tenerife. You stare at it, hear it, letting the colours unfold. Golden streak of tail against a pale green coma. The accompanying caption brags about unprecedented clarity, but your eyes go straight to the shadows. They fall in opposite directions across the frame. Unless Atlas invented two suns, someone misaligned their composites. A gentle unease begins to hum in your chest. You remember the golden rule of data. The cleaner the picture, the dirtier the backstory. Just as you're about to post a snarky comment, you hesitate. Maybe this is the algorithm's fault, the automatic pipeline that merges multiple exposures into one pretty image for the public. Every agency does it. NASA polishes, JAXA embellishes, even the private telescopes crank the saturation knob for the sake of outreach. After all, raw space photos are mostly grayscale. Reality, unfortunately, isn't always Instagram ready. But still, that repeating star pattern, it's too deliberate. You pull up the original FITS file ESA tucked quietly into the data archive. The archive's interface greets you like an old spreadsheet. Dull, functional, and brutally honest. The file there tells a different story. Dimmer tail, no turquoise hue, and the background looks like real randomness. The public image, by comparison, is a theatrical exaggeration. You whisper, well, someone wanted a prettier alien. The discovery doesn't outrage you, it fascinates you. Humans, faced with cosmic wonder, can't resist the urge to curate it. We've been doing that since Galileo sketched the moon smoother than his telescope saw it. Historians still argue whether those sketches were scientific illustrations or artistic propaganda meant to charm the church. Either way, it worked. You zoom in again on the comet's core. There's a faint halo of pixel noise that shouldn't exist in a properly exposed frame. It looks like the remnants of an erased object, something faint, maybe another body, maybe just a sensor ghost. But the way it curves, elliptical and too symmetrical, makes your scalp tingle. You save a cropped version, label it possible companion artifact. Because even if it's nothing, the phrase sounds deliciously mysterious. ESA's press conference begins live as you keep flipping through the photos. A neat row of scientists appears behind a white podium, each flanked by the European flag. One of them, a young data engineer, talks about how the images represent a triumph of collaborative processing. You can almost hear the air quotes. Another speaker mentions a slight compression irregularity, brushing past it with the grace of someone who's rehearsed the line 5 times. You type notes between sips of now cold coffee. Compression irregularity, its repeating star pattern. Metadata mismatch pre-release. Color adjustment acknowledged. Then the live stream briefly cuts to a sleigh. A high-resolution mosaic of Atlas coma. It's mesmerizing. Fractal plumes curling like underwater ink. But at the bottom corner you spot a faint boxy shadow darker than the rest, as though the background has been patched. You glance at the chat exploding with emojis and applause, and you almost laugh. Nobody notices. Everyone's too dazzled by beauty to question composition. It's not malice, you remind yourself. It's marketing. ESA isn't lying, they're storytelling. A comet like this isn't just science, it's funding fuel. The prettier the photo, the easier the next grant. And yet something about the quiet inconsistency nags at you. What else did they adjust for visual contrast? You think of that historical footnote about the Hubble Deep Field, the first ultra-long exposure where NASA left faint cosmic rays unedited, sparking public confusion over white scratches. For weeks, people thought the universe was full of space worms. The lesson then was clear: too much honesty, and people panic, too little, and they start conspiracy blogs. Historians still argue whether public trust in space imagery ever fully recovered. Maybe it doesn't matter. Humans believe in the story more than the stars. Your cursor hovers over the next file. It's titled Atlas Cam 2 Enhanced v3. Enhanced. That word again. You open it anyway. The colour temperature hits your eyes first, unnaturally warm, almost sunset gold. The nucleus gleams like polished copper. You can practically hear the PR team whispering, "Make it inspiring, not terrifying." The longer you stare, the stranger it feels. The comet's tail appears curved the wrong way, defying solar wind and direction. You check the orientation tag. Sure enough, the image has been flipped horizontally. Somewhere in the pipeline, someone reversed space. You sit back and laugh, a quiet, half-delirious laugh. "Congratulations," you whisper. "You just made the cosmos mirror itself for symmetry." You scroll through the ESA's comment section, reading official replies. Whenever users ask about inconsistencies, the agency answers with the phrases like normal, calibration differences, and artistic representation for outreach. Both technically true, both exquisitely evasive. You think of the old NASA practice of painting over film negatives during the early space age. Yes, literally painting to remove dead pixels and scratches. There's an anecdote about 1960s photo technicians using tiny brushes to clean up lunar images before public release. One even joked that he felt like an art restorer working for God. Maybe you muse the same spirit lives on in digital form. The clock on your wall clicks softly, marking the hour. Outside, the morning sun crawls across your blinds, turning your screen reflections into shimmering vertical lines. The comet images, for all their flaws, are still breathtaking. They whisper of distance, exile, and icy endurance. You could forgive any number of Photoshop sins for that kind of beauty, and yet the problem isn't the beauty, it's the pretense of purity. Data dressed as art, truth repackaged as outreach. You imagine future historians digging through these files, wondering which version of Atlas was real, the raw grayscale speck or the turquoise deity we broadcast to the world. Historians still argue about the first photograph ever taken of Earth from space. Was it a blurred weather balloon shot in 46? Or the cleaned, contrast-boosted print that made the magazines? Depends which truth you prefer. You glance again at that cropped halo near the nucleus. The thought creeps back. What if that erasure wasn't just cosmetic? What if there was something beside the comet? A fragment, a companion? Maybe even a probe-sized piece riding the same trajectory? No. You tell yourself, don't chase ghosts, but curiosity has already shifted into gear. The feed updates with ESA's final slide, a clean centered portrait of 3i Atlas, labeled color-corrected composite. The audience applauds. The narrator's voice softens into the outro, thanking viewers for joining humanity's latest step into the unknown. You whisper back to the empty room. Unknown, sure, but maybe cropped for your convenience. Still, you can't deny the thrill. Even imperfect truth is still truth. Even doctored light carries genuine wonder. You save all the files, raw, enhanced, flawed, into a single folder labelled Atlas Photos Real. It's a question you'll keep asking long after the comet itself has passed out of sight. Outside, clouds thicken, like cosmic dust. You close your laptop, feeling that familiar mix of awe and suspicion. The twin engines of every sleepless scientist. You wake the next evening to the soft vibration of incoming alerts. ESA has issued a technical bulletin titled Surface Activity Anomalies in 3I Atlas. You rub your eyes, still foggy from a half-dream about glittering debris fields, and click the link. The document opens with sterile understatement. Localized outgassing detected at latitudes inconsistent with solar heating patterns. You translate that automatically in your head. The comet is venting gas where it shouldn't. You lean closer to the monitor. Jets appear on the shadowed side, the one facing away from the sun. That's like smoke rising downward, or sweat forming in shade. Your pulse quickens. Maybe the object's spinning irregularly, maybe it's cracked open, but even then, something doesn't add up. ESA's diagrams show tiny flares pulsing from the surface in 10-minute intervals, rhythmic as a heartbeat. The explanation box calls it phase-locked sublimation. You whisper the phrase aloud, it sounds like poetry for machines. Still, the rhythm unnerves you. Nature is messy, perfect timing rarely survives the void. You scroll further. The nucleus, they say, is roughly 1 kilometre across but oddly lopsided, like an almond that's been bitten. The rotation model predicts torque-induced stress fractures along its equator. One diagram displays dotted lines that look suspiciously like fault marks. You remember Shoemaker-Levy 9, the comet that split into fragments before colliding with Jupiter in 1994, each piece following the next like a grim parade. You remember those photos, string of pearls across a gas giant's face, and how even catastrophe looked elegant from afar. Historians still argue whether that event permanently changed public fascination with cosmic impacts, or simply gave Hollywood a new genre to overuse. You check the timestamps again. The pattern of jetting grows shorter between bursts. Every cycle releases less gas but more dust. A comet should fade as it loses material. This one brightens. You jot a note. Possible vent clearing deeper ice or something trapped beneath. Then another, more speculative, fragment self-heating. You know you'll regret writing it, but curiosity refuses manners. ESA's livestream replays thermal imagery, ghostly blues and reds swirling like candle flames. You notice one spot glowing hotter than all others, precisely where no sunlight touches. Maybe it's friction from rotation, maybe internal pressure, maybe your inner skeptic interrupts. Maybe nothing. Pixels lie all the time. Still, you can't ignore the symmetry. The plume's shape repeats across multiple frames, as if something under the surface is regulating it. You whisper, "A comet with amnesia," remembering the bullet point title you'd scribbled days ago. It fits. Something about Atlas feels half-remembered, like it's performing the motions of a comet without understanding why. Outside your window, the night air smells faintly of rain. You imagine microscopic dust grains from Atlas, already drifting through the upper atmosphere, invisible souvenirs of another star. Statistically unlikely, but comforting nonetheless. ESA's spokesperson appears on screen, radiating calm professionalism. "We are witnessing complex evolutionary processes," she says, which is agency code for "we don't have a clue." She assures viewers there's no sign of fragmentation. Then, almost as an afterthought, she mentions a temporary loss of one spectrometer channel during the last observation window. The data gap, she says, will be interpolated later. Interpolated, there's that soothing word again. It means filled in by math, not measurement. You chuckle softly. So we're literally guessing prettier numbers. The bulletin continues with compositional data, silicate dust, organic volatiles, and something faintly metallic in the reflected spectrum. They attribute that to micrometeorite contamination, but you frown. Metallic signatures in comets aren't unheard of, yet this one clusters too neatly. It reminds you of an old fringe report about Comet Encke in 1822, when astronomers claimed it emitted a coppery glint visible to the naked eye. Historians still argue whether they saw reality or optical illusion. Maybe both. The rhythm of jetting continues across subsequent datasets. 10 minutes, 9, 8. It's almost like a countdown. You tell yourself not to be dramatic, but the thought won't leave. What if Atlas isn't just leaking? What if it's responding? To heat, to rotation, to something unmeasured. The possibility sits somewhere between science and insomnia. You zoom into a high-resolution close-up of the surface, captured by ESA's long-range imager. It shows dark ridges crisscrossing the crust like dried riverbeds. One corner of the frame reveals a depression, a crater that looks fresher than the rest. Around it, gas plumes curl outward in twin spirals. You sketch the shape in your notebook, realizing with mild embarrassment that it resembles an eye. A blue-green iris staring outward. Your rational side protests. Pareidolia, pattern recognition gone feral. But you can't help tracing the lines again, slower this time. The next data packet lists the comet's rotation period shortening by 2% over 12 hours. That's not just irregular, that's dangerous. Torque from asymmetric jets can tear a small nucleus apart. You recall how Comet Hartley 2 spun faster and began shedding fragments like sparks in 2010, as jets acted like rocket thrusters, twisting the body until it nearly broke. Maybe Atlas is on the same path, only faster, fiercer. You picture it splintering mid-journey, fragments scattering like seeds through sunlight, each carrying the same alien fingerprint. Part of you thrills at the idea. More samples for study, more puzzles to solve. Another part winces. Beauty deserves longevity, even if it's just ice and dust. ESA's commentators discuss contingency plans, coordinated tracking among observatories, updated orbital models monitoring debris potential. The words sound rehearsed, like an emergency drill they never expected to need. You imagine quiet panic behind those calm faces, data scientists whispering about missing packets and unexplained heat sources. You know that tone. You've used it yourself when pretending uncertainty equals control. The livestream cuts briefly to historical context, a montage of past comets, Halley, Tempel 1, 67P, Churyumov, Gerasimenko. They remind viewers that comets are fragile, unpredictable, sometimes downright temperamental. The narrator mentions how ancient Egyptians saw them as omens of renewal, while medieval Europeans considered them fiery swords of doom. Historians still argue which culture understood them better. You grin, maybe both again. When the broadcast ends, you sit motionless, letting the silence settle. The fan hums, the room feels smaller. You replay the last thermal frame in your mind, the heat bloom pulsing under shadow. There's a brief temptation to anthropomorphize it, to imagine the comet breathing. Then you scold yourself, though gently. After all, even scientists need metaphors. They're how you survive staring into endless data. Still, the phrase sticks, a comet with amnesia. Maybe it's not forgetting, it's remembering something we never knew. You stand, stretch, and look outside. The rain has stopped. And the clouds break enough to show a faint smear of stars. Somewhere among them, that 1 kilometer almond is spinning itself toward uncertainty. Jets flaring like faulty memories. You whisper a quiet goodnight, not that it could hear, but because silence feels too final. As you turn off the screen, a final alert pops up on your phone. Data packet 41 corrupted. Manual verification required. You smile tiredly. Of course it is. Out there, Atlas keeps venting secrets. Down here, you keep chasing ghosts made of ice. Morning arrives disguised as a pale rectangle of light against your blinds. You've slept barely an hour, but the ESA dashboard has new thumbnails glowing in the corner of your screen, taunting you awake. The headline reads, Spectral Anomaly, Chromatic Shift in 3-Eye Atlas Coma. Translation, the colour changed again. You rub your eyes, drag the slider open, and there it is, a radiant turquoise plume extending from the comet's dark heart like the flame of a gas burner turned too high. You blink once, twice, certain your monitor calibration is off. You even tap the screen as if it might confess. But the colour stays, brilliant, electric, defiant. The caption below claims it's real data, not a false colour render. That's impossible. No known combination of volatiles should glow that shade at this distance from the sun. Not CO2, not diatomic carbon, not even the cyanogen that paints most comets green. You whisper to the empty room, so what are you then? You pull up the raw spectral graph, eyes scanning the peaks. There, between 470 and 480 nanometers, a new emission line, weak but undeniable. ESA labels it unidentified feature. You chuckle softly. It's the polite scientific way of saying we have no idea. The comet shouldn't be blue-green. It should be dusty grey or faintly emerald, the usual glow from sunlight scattering through outgassed carbon. Instead, it shines like something forged in neon. You imagine it streaking through space like a cosmic firefly, turning the black vacuum into a private aurora. The chat feeds explode with wild guesses. Copper compounds, radioactive salts, alien paint job. You scroll past the noise, but one message catches your eye. Colour doesn't match the black body temp, could be plasma interference. The idea tickles your curiosity. Plasma, ionized gas, could produce that hue if electromagnetic fields were strong enough, but that would require magnetism far beyond what a frozen rock can generate. You jot in your notebook, unexpected turquoise emission, verify magnetic coupling. Beneath it, you doodle a tiny comet with cartoon sunglasses because exhaustion demands humour somewhere. As ESA's analysts present their slides, you notice another curious detail. The colour varies with rotation. Every time the comet completes a spin, the hue deepens, then fades. It's rhythmic, pulsing like a heartbeat again. You remember those earlier jets firing on schedule? Maybe this colour shift is connected. Some cycle hidden under the surface, a heartbeat of chemistry instead of biology. One scientist on the stream dares to sound excited. "We may be observing a new class of volatiles," she says, voice trembling. "Compounds that only form under interstellar radiation conditions." She compares it to when astronomers first discovered tholins, those reddish organic polymers coating Pluto and Titan. Back then, no one believed such complex molecules could form in space. Historians still argue whether the discovery marked the birth of modern astrochemistry or the moment we stopped calling life rare. The parallels make you grin. Every era thinks it's the first to stumble into wonder. Still, the ESA data doesn't line up. The reflectance curves hint at something metallic. You overlay them with known samples. Iron oxide, nickel, even titanium, bun fit. Then you recall a dusty footnote from the Rosetta mission. Early spectra from Comet 67P showed traces of sodium glow near the coma. Brief, faint, never fully explained. Maybe Atlas is reenacting that mystery at full intensity. Historians will argue over this one too. They will debate whether the colour was natural or instrumentation error, whether cosmic rays or processing bias painted the turquoise. You smile at the inevitability of debate. It's science's version of bedtime stories. As you ponder, a memory surfaces. The old Egyptian cosmetics that used ground copper minerals to create turquoise eye paint. Ancient chemistry, same hue. You laugh quietly, imagining pharaohs and comets sharing a colour palette across millennia. Somewhere a museum curator and a space physicist would make an excellent podcast episode together. You enlarge the latest image until the pixels hum. The turquoise aura thickens near one edge, like a seam between layers. You whisper, like glaze on pottery. The thought sticks. What if surface minerals are melting, forming thin films that refract light differently? At high speed and low pressure, even metal grains could behave oddly. ESA's commentary drifts toward caution. They suggest optical interference from dust alignment, a mundane possibility, but their tone betrays hesitation. You recognize that tremor in the voice of a scientist confronted by beauty that defies explanation. It's not fear, it's reverence disguised as doubt. Scrolling through the archive, you stumble upon one raw frame emitted from the public highlight reel. The colour there looks dimmer, but the shape of the coma different, almost structured. There's a faint spiral pattern, delicate but repeating. Spirals imply rotation, sure, but also coherence, some organising force beyond chaos. You take a deep breath. Maybe it's coincidence. Maybe it's artifact. Or maybe Atlas isn't falling apart but reassembling itself. You laugh at your own absurdity. Too many sleepless nights can make even data feel alive. Still, imagination is half the reason science ever moves forward. To ground yourself, you pull out an old book, Edmund Halley's 17th century treatise predicting his comet's return. In the margins, Halley confessed how improbable it felt to think the same comet could circle back centuries later. His peers called it hubris. When Halley's prediction came true, history rewrote the word as genius. You whisper, "Here's to hubris," and toast the comet with your coffee. Another anomaly pops into the feed, a line graph showing polarization angle shifts near the nucleus. That means the light is being twisted, literally rotated, as if passing through magnetic material. The ESA technician mutters something about instrument drift, but you can hear the disbelief even through the lag. Maybe that's the real reason the colour seems alive. It's light dancing through invisible magnetism. You write another note. Possible magneto-optic effect? Investigate polarization. Then joking beneath it, or it's just the universe trolling us. Outside, twilight smears itself across your window like watercolour. You imagine the same turquoise glow far beyond, painting a ribbon across the void. For the first time, you wish you could see it with your own eyes rather than through sterile monitors. The last person to see a truly alien comet with naked eyes might have been a Mesopotamian scribe marking clay tablets with fear and wonder. Historians still argue whether those ancient records describe omens or the first data logs. You decide there's no difference. Both are ways of saying, look up. Your phone vibrates, a push alert. ESA disables public colour, feed pending verification. You sigh. So the turquoise is on pause, censored by caution. The official line will be calibration error. Always is. You can already predict tomorrow's press release. Still, you've seen it. You watched the impossible shade shimmer across pixels, watched scientists hesitate between truth and presentation. Whether real or not, the colour now exists. In data, in speculation, in memory, that's enough. You lean back, letting the fan's hum merge with the slow rhythm of your breath. The comet, somewhere out there, spins beneath alien light. Its turquoise flare might be fading already, or maybe it never existed beyond algorithmic imagination. But you hold on to it anyway, the way people hold on to dreams long after they wake. Because maybe that's the purpose of cosmic visitors, to remind you that even the coldest ice can surprise you with colour. The turquoise glow fades from ESA's headlines almost overnight, replaced by careful silence and a single sentence buried deep in a press memo. Colour calibration discrepancy under review. You read it 3 times, shaking your head. That's bureaucracy's way of saying we're pretending this didn't happen. But then, something else catches your attention. The new data link just below the disclaimer. You click it, expecting the usual cleaned summaries, but what you find instead is a missing page. 404 data not found. You blink, reload, refresh, same message. The file you downloaded yesterday, the one containing that unprocessed frame with the faint spiral pattern, has vanished. It's gone not only from the public archive, but also from the mirror repositories used by independent research networks. For a moment, your mind cycles through rational possibilities. Server migration, naming errors, maybe ESA reorganizing files. Yet your gut twists. This doesn't feel like maintenance, it feels like erasure. A forum post appears within minutes. Someone under the handle Cryospectre screenshots the same 404 and writes, "They pulled the turquoise data." Within an hour, the thread balloons to hundreds of comments, half curious, half furious. You watch the digital wildfire grow. Some claim ESA servers were hacked. Others suspect a soft lockdown. You smirk because, of course, in 2025, every mystery is either sabotage or censorship, but you can't dismiss it entirely. The next time you log into ESA's observation dashboard, your account pings an unfamiliar note. Access restricted, verification pending. You tilt your head, half amused, half unsettled. You're not even on their payroll, just an obsessive civilian with too much curiosity and not enough sleep. So you take a deep breath, switch tactics, and go digging through cached data. The internet, after all, never forgets completely. And there it is, a low-resolution backup of the deleted frame still lingering in a research aggregate server in Brazil. It's grainy, pixelated, but unmistakable. The same spiral pattern, the same faint turquoise haze, timestamp identical to the missing file. You feel a thrill sharp enough to slice through fatigue, proof or at least the ghost of it. The next few hours dissolve into digital archaeology. You cross-compare the deleted frame with ESA's official composites and spot something new. In the lower quadrant, nearly invisible unless brightness is boosted, there's a thin filament of light, a hairline streak cutting diagonally across the coma. It could be cosmic ray interference, the bane of deep space imaging, yet the line persists across 4 frames taken 30 seconds apart, identical position and angle. Cosmic rays don't repeat like that. You stare at it until your coffee cools to room temperature. So, you murmur, either the universe likes straight lines, or someone's editing out the wrong pixels. It's not the first time a data has disappeared under mysterious timing. You remember 2014? The Rosetta mission's sudden blackout during its descent to Comet 67P. The feed went dead for 20 minutes, and the agency blamed telemetry buffering. Historians still argue whether anything significant happened in that blackout, though the official photos later showed minor inconsistencies around the landing site. You grin at the thought that maybe history is repeating itself, this time with an interstellar twist. Your inbox pings, a message from an astronomy listserv you follow. Subject line, Public Archive Rollback Notice. The text inside is clinical. Due to ongoing validation procedures, imagery sets 38 to 44 have been temporarily removed. You check the file index. Those are exactly the turquoise frames. Coincidence, perhaps, but your skeptical brain doesn't believe in coincidences after 3 a.m. To clear your head, you step outside. The night air tastes metallic, rain just waiting to happen. Above the streetlight glare, Orion's belt gleams faintly. Somewhere beyond that pattern lies the path Atlas followed in. You imagine its faint glow, invisible from Earth, still shedding dust that will outlive all your suspicions. You recall another historical footnote, when astronomer Maria Mitchell discovered comet 1847-6 and had to fight for credit because the official records were conveniently misplaced. Historians still argue whether that was sexism or just bureaucratic chaos. Either way, data disappearing has always been part of astronomy's messy romance. Back inside, you refresh the ESA feed one last time. The interface loads slower than usual, like it's stalling for breath. The turquoise anomaly is officially replaced by a grayscale placeholder reading. Reprocessing in progress. The missing data isn't just missing, it's been overwritten. You whisper, well played. Still, people keep talking. Fringe sites post blurry screenshots of your recovered frame before you even think about sharing it. A video titled ESA Cover-Up Interstellar Object Emits Artificial Light racks up 500,000 views overnight. You wince at the thumbnail. Someone's overlaid the comet with glowing circuitry. The internet ruins everything, but at least it keeps mysteries alive. By morning, ESA releases a new statement. No data suppression has occurred. Certain files were corrupted and will be reissued after calibration verification. It's calm, professional, and utterly unconvincing. You've read enough PR to hear the unsaid. Corrupted means we decided you shouldn't see it yet. Your phone buzzes again. This time with a direct message from an old acquaintance, a grad student you once mentored during a summer internship. Her text is brief. You didn't hear this from me, but we were told not to mention the turquoise frames in any external communication. You stare at the message, heart tapping double time. Why? You type. Her reply arrives after a pause. Because it wasn't turquoise in all instruments. Some cameras didn't see it at all. You lean back, letting that sink in. The colour wasn't universal. Maybe it wasn't real. Maybe it was software blending multiple filters into fiction. Or maybe, more intriguingly, it was visible only from certain observation angles, like polarized light reflecting off something smooth. You scribble a new note. If colour depends on angle, could imply surface reflectivity, not emission. Outside your apartment, thunder rolls low and lazy, echoing like cosmic static. You close your eyes for a moment, imagining the comet tumbling through emptiness, reflecting a colour that some cameras see and others miss. Maybe the universe is simply reminding you how little you really know. Then again, knowledge has always come wrapped in erasures. Every discovery leaves shadows behind it, data lost, files overwritten, questions dismissed for convenience. Historians still argue whether early radio astronomers deleted entire hours of static that might have included the first signs of pulsars. You smile. Maybe the same mistake just happened again. You save your surviving copy of the deleted frame on 3 separate drives, encrypt it, label the folder Turquoise Ghosts, and shut your laptop with exaggerated care. Somewhere out there, 3i Atlas keeps venting, spinning, vanishing beyond the next planetary orbit. And down here you keep collecting its digital fingerprints, one disappearing bite at a time. Maybe that's the real story. Not the comet's mystery, but our refusal to let it stay silent. By the time you finally fall asleep, your brain is still orbiting that single missing file like it's the sun itself. When you wake, the news cycle has already moved on. To a half-hearted ESA press briefing, a few polished sound bites about ongoing analysis, and then, somehow, the inevitable comparison headline, 3R's Atlas versus Oumuamua, are we seeing a pattern? You grin through a yawn. Of course they brought up the old visitor. The first interstellar object never truly leaves a conversation. It just drifts quietly in the background like a celebrity who refuses to age. You scroll through the articles, the familiar photographs flashing past, Oumuamua's cigar silhouette, the grainy trajectory plots, the red-brown reflectivity curves that no rock or comet ever quite matched. Back in 2017, everyone had an opinion. Some called it a fragment of an alien light sail. Others insisted it was just a flattened chunk of nitrogen ice. Historians still argue whether that debate marked the moment serious scientists finally started saying aliens without giggling, or the moment they surrendered all sense of restraint. Now, with Atlas glowing turquoise and shedding files like dead skin, the déjà vu feels almost scripted. You tap the desk in slow rhythm, muttering "different year, same panic." The ESA briefing does nothing to help. The lead analyst, stern to sleepless, admits that Atlas's orbital solution has non-gravitational residuals. That's bureaucratic jargon for it's moving weirdly again. You jot a note, acceleration unexplained again, history repeating like a bad sequel. The livestream chat loses its collective mind. One user types, "So it's another light sail, right?" Another replies, "We're being breadcrumbed." You almost choke on your coffee. Humanity can't resist turning the cosmos into a conspiracy thriller. But you can't blame them. When patterns repeat, our brains reach for narrative. Still, the parallels are uncanny. Oumuamua's acceleration, Atlas's turquoise's flash, both accompanied by disappearing data sets and nervous press releases. Even the phrasing echoes. You find the archived transcript from 2018, NASA scientists calling Oumuamua's motion consistent with outgassing not directly observed. ESA just said almost the same about Atlas, only now they add thermal modelling inconsistent with observed acceleration vector. Translation: the math refuses obedience. You open both objects' orbital plots side by side. The lines, one from years ago, one from now, bend across your screen like twin scars. Different directions, different inclinations, but something about the curvature feels too poetic to ignore. You overlay them, shift transparency, and for a heartbeat they cross paths. Oumuamua's exit trajectory slicing through Atlas's entry corridor, separated by space but united by geometry. It's meaningless, you tell yourself, but it looks beautiful, and beauty in data is always suspicious. A sudden memory flickers the day Oumuamua's discoverer confessed in an interview that he'd felt uneasy describing its motion as natural. You remember the collective gasp that followed, the avalanche of op-eds both mocking and defending him. Historians still argue whether that single sentence cracked the door open for imagination or slammed it shut. You suspect both. ESA's stream plays in the background, its tone sliding between fascination and damage control. "We are not drawing premature conclusions," says the director, which usually means they already have but don't dare voice them. One slide behind him shows Atlas' light curve, a jagged sawtooth pattern that shouldn't exist. Rotational modulation perhaps, yet the period keeps shifting as though the object can't decide how fast to spin. You imagine Atlas tumbling through the void, its turquoise halo flickering like an indecisive heartbeat. A kindred spirit to Oumuamua's silent glide. Maybe the universe sends us lessons in repetition until we learn humility. The chat next to the stream scrolls faster. "What if they're from the same system?" one comment reads. The idea catches you. If both visitors came from the same distant nursery, some forgotten star flicking fragments outward like seeds that would make this a reunion of cosmic siblings. You grin. It's absurd, romantic, and faintly possible. The trifecta of good science fiction and great science. You run a quick back-of-the-napkin calculation. The travel times don't match perfectly, but if they were ejected millions of years apart from a binary system, the trajectories could align given enough chaos. You write in your notebook, check Vega or Lyra origin hypothesis. That region again, always Lyra, like the universe keeps humming the same chord. Outside, dusk melts the edges of your apartment into violet haze. You open a window and the chill carries the faint smell of rain and car exhaust, your local version of a comet's tail. Somewhere above, 3i Atlas is hurtling past Mars's orbit, leaving a whisper of turquoise ions in its wake. You remember when scientists first tracked Oumuamua's tumbling, one rotation every 7.3 hours, irregular as if the object were shaped like a chipped coin. Its brightness flickered unpredictably, each flash a clue written in Morse code no one could decipher. Now Atlas echoes that dance, its brightness stuttering out of rhythm. You wonder if the cosmos is trying to rhyme. ESA's analyst mentions an intriguing detail. Spectral readings suggest that Atlas' surface albedo, its reflectivity, rises sharply on one hemisphere. That could mean metal or glass or something melted smooth. You mutter, so half rock, half mirror. Then you recall Oumuamua's own mirror-like glint. The coincidences keep stacking until your skepticism starts feeling like denial. Still, your better judgment tethers you to Earth. Natural explanations exist. Outgassing, sublimation, dusty coatings, solar radiation pressure. The problem is, every new explanation needs its own patch kit. Science feels like duct tape lately. Functional but never elegant. You scroll further, finding a paper draft circulating among peer reviewers. Its abstract suggests that the recurrence of anomalous interstellar visitors may indicate observational bias rather than astrophysical pattern. Translation. Maybe weird rocks have always passed through, and we only just learned to notice. The humility comforts you. Maybe the universe hasn't gone mad, just our instruments have grown sharper. But even humility doesn't erase the thrill. You imagine a future historian reading your notes, seeing both names, Oumuamua and Atlas, scribbled side by side in the margins. They'll probably roll their eyes, dismissing this era as the romantic phase of exocomet studies. Historians still argue whether romance hinders discovery or drives it. Tonight, you know the answer. It does both. You close the feed and sit back, letting the hum of your computer blend with the city's distant traffic. Somewhere out there, two interstellar travelers have crossed paths across centuries carrying stories carved in frozen chemistry. Maybe they're mere coincidences, maybe they're verses of the same poem. Either way, they've found an audience. You. You whisper into the stillness, half joking, half reverent. Thanks for the encore. The next morning, your screen is awash in colours. Spectral charts, heat maps, and emission profiles so dense they look like abstract art. ESA has released a full chemistry set for 3E Atlas, and you dive in like it's a breakfast buffet. You don't even bother with coffee first. Numbers this weird deserve your undivided, slightly delirious attention. At first glance, it's textbook comet chemistry. Water ice, carbon monoxide, carbon dioxide, ammonia, a pinch of methanol. You mutter, yep, space snow cone. Nothing shocking. But then you scroll further down and see something that makes you pause mid-sentence. Anomalous spectral reflectivity between 1.1 and 1.3 microns, not attributable to known volatiles. In plain English, that means part of the light coming off Atlas behaves as if it's bouncing off a material we've never catalogued. You run the numbers twice, just to be sure you're not hallucinating. The ratio of infrared to visible light implies a surface that acts like glass when it shouldn't. Maybe it's frozen hydrocarbons polished smooth by cosmic rays. Or maybe, your inner conspiracy theorist whispers, it's something intentionally smooth. You shake your head at yourself. It's far too early in the day for alien mirror theories. ESA's commentary, predictably, stays cautious. Reflectivity anomaly may result from preferential crystal alignment of carbonaceous compounds. Translation. We'll call it fancy soot until proven otherwise. Yet you sense their excitement through the subtext. The graphs dance with irregular peaks, a chaotic symphony that shouldn't exist in natural ice. You lean closer to the monitor, nose almost brushing the screen. The absorption bands around 2.7 microns look familiar, but they've got jagged shoulders, tiny deviations. That's when you remember a paper from the 90s describing liquid crystalline ice, a phase that exists only at the razor edge between solid and fluid, structured like glass yet flowing on a molecular level. Back then, no one believed it could occur outside the lab. Historians still argue whether the experiments even happened or if the data were misinterpreted. But if those bands are real, you're staring at proof. The idea grips you. Imagine ice that behaves like a slow-motion fluid, bending light and heat in ways no model predicts. Imagine the comet's surface shimmering with microscopic rivers frozen mid-flow. You laugh softly, almost giddy. A comet wearing designer armour, you whisper. The feed updates with the new measurements, temperature maps from an ESA spectrometer in orbit. The glass patches register 30 degrees warmer than the surrounding crust. That's absurd. Either the comet is leaking heat from within, or sunlight is focusing like through a magnifying lens. Either way, the word frozen feels obsolete. You make a note: crystalline behaviour plus thermal gradient not inert. That phrase sits on the page like a pulse. Another section of the report grabs you: the detection of ionised carbon chains stretching unusually long, up to 12 atoms. In laboratory terms, that's like finding spaghetti in a soup of crumbs. Long carbon chains are precursors to complex organics, the first ingredients of life's chemistry. You pause, exhale slowly, and remind yourself that precursor to life doesn't mean life. It's like finding flour and deciding you've baked a cake. Still, the thought flickers. Maybe interstellar space isn't as sterile as it seems. Maybe comets like Atlas are delivery trucks for the universe's recipes. You imagine them wandering between stars for eons, seeding molecular possibility wherever gravity allows. It's a comforting idea that life's raw ingredients travel second class, hitchhiking on cosmic ice. You flip to the next page of data: isotopic ratios. The deuterium to hydrogen fraction is off by a factor of 3 compared to Earth's oceans. That suggests the comet didn't form anywhere near our sun. In fact, it points toward a colder, more ancient nursery. You grin at the sheer distance implied. You're studying chemistry older than the solar system, older than every fossilized dream on this planet. ESA's analysts discuss potential contamination, whether sunlight or solar wind could have altered the readings. But you know the signature's too clean, too sharp. Something about it feels preserved, like a message kept in vacuum since time began. You scribble: ice that remembers another star. Outside, wind rattles your window pane, and for a moment it sounds like faint static, the universe clearing its throat. You glance up from your notes, eyes burning, and realize hours have slipped by. The screen now shows composite renders, the comet's nucleus reconstructed in false color. Bands of yellow, orange, teal, beautiful and nonsensical. One region near the southern pole glows a pale violet that shouldn't exist in that palette. You laugh again. Even its chemistry refuses color theory. In the chat, one commenter jokes, maybe it's leaking space Gatorade. Another adds, ESA hiding the flavor name. You almost choke on your drink. Humor is the final defense against awe. Yet the deeper you dive into the numbers, the less funny it becomes. The ratios of heavy metals, nickel, magnesium, and a whisper of cobalt cluster in patterns resembling terrestrial meteorites, not pristine comets. That suggests violent history, maybe a planetary collision. You imagine Atlas as a refugee, a splinter ripped from a doomed world and frozen mid-flight. If so, its smooth reflective surface might be vitrified crust, melted, refrozen, immortal. You recall how fragments of Earth's own crust occasionally escape during massive impacts, cast into space as rocky ambassadors. Some even return centuries later disguised as meteorites. Maybe this is another planet's version of that, a memory returning to no one. Historians will someday argue whether calling it alien is even accurate. After all, if every world hurls pieces of itself outward, then the universe is one vast exchange program of debris. You scroll to the last section, laboratory simulations. ESA's chemists tried replicating the spectral anomaly by blasting mixed ices with ultraviolet light in vacuum chambers. None reproduced the turquoise emission or the heat differential. Their conclusion: spectral variance remains unexplained, may require non-equilibrium quantum effects. You whistle softly. That's science's way of shrugging in disbelief. You sit back, rubbing your temples. A faint dizziness hums behind your eyes. Maybe it's the lack of sleep. Maybe it's the vertigo of realizing that nature is still inventing phases of matter, while you struggle to invent metaphors. Outside, the evening hum of traffic rises like background radiation. You picture Atlas gliding silently through the dark, its crystalline skin catching sunlight, flashing turquoise and violet like an interstellar jewel. Somewhere within that shimmer, atoms rearrange themselves into new patterns you'll never touch but can almost imagine. You close your notebook, whispering to the empty room, whatever you're made of, you win. Then you laugh softly, because the comet doesn't care. It's too busy being beautiful in physics you barely understand. You wake to the hollow ping of a news alert. ESA has scheduled an unscripted briefing, the kind they only call when something has either gone very right or very, very wrong. The subject line reads simply, Kinematic Update, Unexpected Morphological Evolution of 3i Atlas. You exhale through a grin. Translation: the comet has decided to ignore its script again. You click the stream link. The feed loads slowly, buffering just long enough to make you suspicious. When the video stabilizes, you see 3 familiar faces from the mission team, flanked by their monitors displaying new imagery. One of them, a data scientist with the tired posture of someone who's been awake for 40 hours, speaks first. Atlas has exhibited transient splitting activity, she says, voice brittle but calm. Multiple bright points have been detected trailing the primary nucleus. Your mind translates faster than her words. The comet might be breaking apart. You lean closer. The displayed image shows a faint streak of light, followed by 3 smaller dots, like pearls on a fraying string. At first, you assume it's an optical illusion, camera ghosting or cosmic rays, but then the image updates and the pattern persists. It's not artifact, it's reality. The lead engineer explains that the fragments seem to have detached simultaneously, each following slightly diverging paths but maintaining relative formation. They're not random, she says, and the chat feed explodes with question marks. Not random, 2 words that never belong near comets. You grab your notebook and scrawl fragmentation event, structured separation. Then another line, not natural symmetry. You pause, the pen hovering, unwilling to write what you're thinking. ESA's next slide shows brightness curves, each fragment flickering with a synchronized pulse roughly every 10 minutes. The same rhythm the comet's gas jets followed earlier. It's as if the dismembered pieces are still keeping time with their parent, like clockwork gone feral. You whisper, still breathing in rhythm. A small smile flickers on the scientist's face, one of disbelief rather than joy. We cannot currently explain the coherence, she admits. Thermal stress is an unlikely cause. The fragments are cooling faster than our models predict. You almost feel sorry for her. Years of equations undone by a lump of misbehaving ice. Then another voice chimes in, this one from a historian of astronomy invited to provide context. He mentions how comets have been surprising humans for millennia, how in 1106, the so-called Great Comet of that year split into multiple visible pieces, terrifying Europe and Asia alike. Chroniclers wrote of stars giving birth. Historians still argue whether that was superstition or early observation of fragmentation physics. You grin. Apparently every era's scientists end up humbled the same way. ESA display switches to infrared imaging. You squint. The trailing fragments glow faintly warmer than the main body. That's wrong. Detached pieces should cool, not heat. The commentator offers one possible explanation. Exposed volatile pockets might be sublimating, but you hear the hesitancy in his tone. Sublimation alone can't explain synchronized heating. A smaller inset window pops up showing simulation data, model runs of a comet breaking under torque. In all of them, fragments scatter chaotically. None form neat strings. You mutter, physics refuses choreography, and yet here it is, pirouetting across your screen. For a moment, you forget your skepticism. You just watch, mesmerized as the faint dots drift together, like fireflies choreographed by the unseen hands. You imagine if ancient astronomers could see this, they would call it divine mechanics, a celestial heartbeat visible through ice. Maybe they weren't wrong. A message appears at the bottom of the feed. Live feed interruption due to telemetry drop. You groan again. After a few seconds, the screen flashes to ESA's logo, then to looping background music that sounds suspiciously like lullaby-grade ambient synth. You laugh. At least they picked calming panic music this time. You check the mission's public data board. No new frames uploaded. The fragmentation event is listed as pending validation. You tap your fingers against the desk, rhythm matching those 10-minute pulses you can't get out of your head. The online rumor mills ignite instantly. Some claim the fragments are artificial probes detaching for independent navigation. Others declare them crystalline shards reflecting the same sunlight at perfect intervals. A few insist ESA is testing AI algorithms to see how long it takes people to cry aliens. You roll your eyes, yet you keep scrolling. Because honestly, who wouldn't? You remember the Shoemaker-Levy impact again, the way its fragments lined up like a procession before striking Jupiter. But that event followed gravity's logic. This one feels intentional. You hate yourself for even thinking the word, but it lingers. To clear your head, you run your own crude orbital extrapolation using the released coordinates. The trajectories curve neatly, diverging slightly before realigning downstream, as though magnetic fields, or some residual tether, link them. You mutter, Gravitational resonance? Electromagnetic coupling? None of it quite fits. You flip through your notebook, pages filled with the prior notes: turquoise emission, rhythmic venting, crystalline skin missing data, now fragments pulsing together. The pattern of repetition grows too tempting to ignore. Maybe coincidence is the universe's favourite joke. Your phone buzzes, a text from your grad student contact again. Off record, team found transient magnetic signature between fragments. Low amplitude but rhythmic. You stare at the message until the words blur. Magnetic. Rhythmic. The hairs on your arms lift. You type back, "Could it be interaction between charged dust streams?" The reply comes minutes later. Maybe, or maybe something else. That last phrase echoes louder than it should. Outside, the world moves normally. Cars, neighbours, dull urban hum, but you feel suspended in a different tempo, though your heart beats syncing unconsciously with the 10-minute cycle. You check the time, realise another pulse should occur right now. You imagine far beyond the sky, those fragments blinking in unison, tiny beacons marking each other in darkness. ESA resumes the feed hours later, but the footage looks cleaner, quieter, too perfect. The trailing fragments now appear faint and symmetrical, stripped of irregularity. The spokesperson calls the prior anomalies data artifacts exaggerated by compression. You sigh, both relieved and disappointed. Of course, you whisper, the universe fixed itself in post-production. You close the stream and lean back. The fan hums, steady as ever, reminding you that rhythm can exist without meaning. Yet as you stare at the ceiling, you can't shake the image of those synchronized lights, frozen echoes of something ancient, perhaps mechanical, perhaps merely mathematical. Either way, they've left a pattern inside you. Maybe Atlas isn't falling apart. Maybe it's just revealing that even in disintegration, there's choreography, an elegance chaos can't erase. You spend the rest of the night replaying that formation sequence, frame by frame, until dawn stains the sky a watery grey. The fragments of 3i Atlas drift across your screen like a slow-motion symphony of disobedience. Each pulse, each flicker, perfectly timed, perfectly insolent. But something new has surfaced overnight. A thread on a professional astronomy forum, quiet and careful, titled "Unidentified Trailing Signature in ESA Imagery." You click. The first post includes a high-contrast still taken from ESA's latest release. Zoom deep into the background. There, faint but undeniable, is another object, not another fragment, a shadow. It trails behind the main comet at a steady distance, barely brighter than cosmic noise, shaped more like a spindle than a sphere. It's the kind of faint smear you'd usually dismiss as a camera glitch, except this one moves, frame to frame, always keeping pace. You freeze, heartbeat climbing in disbelief. The poster describes it as an artifact caused by a solar scattering, but even in the stills, the thing has coherence. You drag the images into your software, align them, and layer transparencies. The result makes your skin prickle. The faint spindle doesn't just follow, it adjusts position as though actively orbiting the comet's centre of mass. You sit back, whispering, "That's not dust." Within hours, the post vanishes from the forum, replaced with a cheerful moderator note. Thread closed for speculative content. Classic. You refresh twice, then check your email. Nothing. You half expect ESA to send a polite warning to stop poking around. Instead, the silence feels heavier, more strategic. The next official update calls the trailing mark an internal reflection caused by bright jet emissions. You laugh out loud. Internal reflections don't maintain orbital dynamics. Nice try, you mutter. Still, their explanation spreads faster than your skepticism ever could. You scroll further, past the press release, to a footnote. Subsequent frames show no persistence of the artifact. You raise an eyebrow. Of course they don't. Someone cropped them. For sanity's sake, you dive into history. You find an old account from 1858 when astronomer Giovanni Donati sketched a comet with what he described as a smaller companion star, faint yet constant. His contemporaries mocked him, claiming optical ghosting. Historians still argue whether Donati was hallucinating or glimpsing an actual binary nucleus. You can almost hear his ghost chuckling in solidarity. Back in the present, your own eyes ache from staring too long. You dim your monitor, step onto your balcony and breathe in cold air. Somewhere beyond the city's sodium glow, Atlas hurtles through vacuum, dragging its ghost companion behind it. Maybe it's nothing more than a rogue fragment caught in gravitational resonance. But the precision bothers you. It doesn't wobble, doesn't drift. It's too obedient for the chaos. You whisper to yourself, the strange shadow behind it, echoing the title you once wrote in your outline. It's almost comforting, like you've been expecting this. When you return to your desk, a new direct message waits from your graduate student contact. They ran polarization filters on the latest frames. The shadow doesn't polarize like dust. It's reflective, not emissive. Reflective? Your pulse trips. Reflective means light isn't coming from it. It's bouncing off it. Something smooth, maybe metallic. You type back, "Any estimate on size?" She answers, "Between 50 and 70 meters long, too big for debris, too stable for gas." Then, after a pause, "They're calling it an observational illusion for now." Of course they are. You stare at the monitor, the faint outline glowing like an afterimage burned into your vision. 50 meters, a perfect length for a shard, a monolith, or a probe depending on your taste in science fiction. You can't help but smile at the absurdity. "If it starts sending Morse code, I'm quitting," you whisper. Still, something deep in you resists dismissing it. Because if this shadow is real, it raises uncomfortable questions. How did it match the comet's speed? Why did its brightness pulse exactly half a phase out of sync with the main nucleus? That kind of coherence doesn't happen by accident. To keep your imagination from combusting, you bury yourself in physics. You calculate the probability of a naturally captured fragment maintaining synchronous orbit. The odds roughly 1 in 10 billion. You run the math again, change the parameters, fudge the uncertainties, it doesn't help. Numbers remain unromantic, and they're telling you this shouldn't exist. You remember a story from the Soviet space archives about comet Arend-Roland in 1957. Its tail bent forward instead of backward, defying expectations. Observers at the time swore they saw a luminous companion sphere preceding it. Historians still argue whether that anomaly was optical illusion or atmospheric distortion. You grin. The universe has always enjoyed repeating its best pranks. ESA's next transmission offers high-resolution updates. Dozens of images, carefully calibrated, all cropped tighter than before. The tail now ends exactly where the shadow used to begin. You laugh softly, shaking your head. You can erase pixels, but not curiosity. The online community doesn't buy the silence either. Hashtags bloom like weeds. Comet Shadow, #Atlas Companion, #ESA Hide and Seek. Amateur astronomers flood social media with grainy telescope footage, most showing nothing but noise. Yet in the chaos, one video stands out, a brief clip from an observatory in Chile. It's shaky, blurred by wind. But there it is, a faint secondary glint following the comet, maintaining perfect distance. The uploader writes, "Maybe we're seeing something magnetic." That word again, magnetic. It ties everything together. The rhythmic pulses, the synchronized fragments, the polarized light. You add it to your growing list of coincidences and wonder if coincidence has a threshold beyond which it becomes design. Outside, thunder trembles across the horizon, mimicking the low rumble of your thoughts. You dim the lights, replay the clip, and let the hum of your fan blend with the rhythm of your heartbeat. The shadow drifts across the screen again, elegant, deliberate, impossible. You imagine if it's real, an interstellar hitchhiker following a comet as camouflage, its surface polished enough to hide in reflected light. Maybe not technology, maybe not even intention, just a relic of something older than comprehension. A seed, a shard, a messenger made of semblance, so as you shut the screen, the glow lingering behind your eyelids. Whether artifact or anomaly, it's there now, living rent-free in your imagination. You smile despite yourself. "Fine," you murmur. "Keep your secrets, Atlas. I'll keep watching." And somewhere in the dark, the universe blinks back. Maybe coincidence, maybe acknowledgement, maybe both. You tell yourself you're going to take a break, walk outside, touch some grass, remember the existence of a world that isn't rendered in ESA telemetry blue. But the lie doesn't hold. You come back 2 minutes later, because a new packet has dropped into the public archive, and your brain has the attention span of a caffeinated ferret when mystery is involved. The headline reads, Dust Particle Composition Dataset, Preliminary 3i Atlas. In smaller print, use with caution, discrepancies noted. You grin. The best kind of data always arrives with a warning label. You scroll through the numbers, most of it as comforting and familiar as the texture of old equations. Silicate ratios, volatile mass fractions, density approximations. Then your eyes snag on a small table halfway down the sheet. Under non-volatile grains, someone has listed ferromagnetic response, inconsistent. You blink, lean forward, read it again. Ferromagnetic. Comet dust shouldn't be magnetic, at least not strongly. That's the sort of word that belongs to meteorites or laboratory alloys, not frozen gravel from interstellar nowhere. You mumble, "Oh, come on, Atlas. You're supposed to be made of boredom and snow." The accompanying notes mention the magnetic readings flickered in precise intervals during sample tracking, the frequency once every 600 seconds, 10 minutes, the same cursed rhythm again. You laugh low and tired, rubbing your eyes. So even your dust keeps time? ESA's spokesperson attributes the pulses to instrumental interference with telemetry clocks. You almost admire the creativity. Historians will probably argue someday whether agencies invented euphemisms or merely perfected them. You dig deeper into the composition table. Nickel levels are high, almost meteoritic. Iron content, 2. The ratio of nickel to iron hovers near 7.3%, almost identical to the ratio found in metallic meteorites that once melted inside real planets. That's not comet material. That's planetary core material. You scribble the words planet fragment in this margin, then immediately add too dramatic check assumptions, but the thought stays anyway. The dust's morphology is equally weird. Micron-sized grains showing hexagonal symmetry, ordered, crystalline, not amorphous. You stare at the electron micrographs attached at the end of the report, and your mind can't decide whether they look more like snowflakes or circuit boards. An ESA analyst explains in a recorded briefing that the pattern likely results from columnar ice growth along vapor pressure gradients. He smiles in the way scientists do when they know the explanation barely holds water. The comment section beneath the recording has already turned chaotic. One viewer writes, "Looks manufactured." Another replies, "Everything looks manufactured if you're tired enough." You chuckle, appreciating both sides. Still, those tiny symmetrical patterns haunt you. They remind you of early crystal radios, simple coils and lattices pulling music out of static. Maybe the cosmos has been building its own receivers all along, structures tuned not to sound but to sunlight. It's a silly metaphor, but it warms the imagination. You look again at the grain-size histogram and notice another oddity. The smallest dust particles aren't spherical but elongated, like tiny needles. That geometry aligns suspiciously well with magnetic alignment phenomena. The dust could be orienting itself along a field, real or residual. That would explain the rhythmic signal. But if Atlas carries a magnetic field strong enough to align dust across kilometers, something extraordinary sits inside it. Iron core superconducting inclusions, or your favorite absurd option, alien ship debris. You grin at your own absurdity, then jot, "Check magnetization thresholds for carbonaceous ice" in the notebook margin. The more you read, the stranger it gets. Some grains show trapped bubbles filled with noble gases, argon, neon, xenon, in concentrations that don't match any solar abundance pattern. The isotopic ratios are shifted as if they were formed near a different kind of star. You whisper, "So you really are from somewhere else." The phrase feels both confirmation and confession. ESA's modelling team suggests Atlas might have originated around a red dwarf system, where prolonged stellar flares could drive exotic chemistry. It's plausible but unsatisfying. The model assumes chaotic processes, yet the data sings in patterns. Randomness shouldn't hum in harmony. For a brief escape, you read a sidebar essay by a mission historian included in the report, something about how centuries ago, alchemists believed comets were literal celestial metals being forged in heaven, dropped occasionally to inspire kings or doom them. He writes, "Historians still argue whether the metaphor preceded the superstition or the other way around." You smile. The line sounds like something you would have written. Back to the data. One column labelled magnetic moment variance pulses through your vision like Morse code. Every other entry shows spikes in neat intervals, exactly matching that 10-minute cadence. You feel your scalp tighten. It's not just noise, it's organised noise. The magnetic readings rise and fall with mathematical precision. You overlay the magnetic curve with the light curve from the fragmentation event and nearly drop your pen. The two waveforms align perfectly, offset by half a phase. When the brightness of the comet dims, the magnetic intensity peaks, as if energy swaps between light and field. You whisper, "energy breathing," then laugh because you know how crazy that sounds. To calm yourself, you check independent observatory's data. The Japanese team at Subaru reports similar fluctuations, though weaker. They dismiss it as instrument drift. You sigh. Science often hides its awe behind calibration errors. Theories bloom in your mind like over-caffeinated flowers. Maybe it's piezoelectric it's from the crystal-like ice layers flexing as the comet spins. Maybe it's charge separation in dusty plasma. Or maybe your inner insomniac dares something more deliberate. After all, magnets remember. They carry patterns like handwriting in metal. What if this dust is trying to write? You picture it. Each grain, a microscopic archive from another world, humming quietly in rhythm, a cosmic Morse that no one bothers to decode. You smile, aware of how poetic and unscientific you've become. But poetry feels safer than the alternative, admitting you don't know anything at all. Your computer pings again. ESA conference summary uploaded. You open it, scroll to the last line and laugh out loud. The official stance reads, "No evidence supports non-natural magnetic organization. Phenomena likely coincidental." You whisper, "Of course, coincidence again." Outside, the wind rattles your windows, sounding for all the world like sand pouring through a vast hourglass. Somewhere out there, Atlas spins, shedding metallic dust like glitter. Each particle is sound, aligning and misaligning in patient rhythm. You close your eyes and imagine floating beside it, surrounded by drifting shards that hum faintly, vibrating in invisible fields. Maybe you'd hear music, maybe silence. Either way, you'd understand that even poor dust can keep time. The next update from ESA arrives without warning, a cold drop of information disguised as routine housekeeping. Rotational stability anomaly observed, further modelling required. You read the phrase twice, feeling your pulse quicken. When bureaucrats use the word anomaly, it means the laws of physics have filed a complaint. You refresh the mission dashboard and watch as the numbers crawl across your screen, each one whispering that 3i Atlas is once again rewriting its choreography. According to the new data, the comet's rotation period has shortened from 7 hours to 4.5 in less than 2 days. That's impossible unless some internal torque is accelerating it. Natural jets could do that, but the measured gas emissions remain steady. Something unseen is spinning it faster, like a phantom hand on a cosmic crank. You stare at the graph showing the change in angular momentum. The curve isn't smooth, it pulses, rising and falling every 10 minutes. That cursed rhythm again. You laugh softly, half disbelief, half exhaustion. "All right, universe," you murmur. "I get it. You own a metronome." ESA's analyst on the live stream smiles too tightly, saying, "The rotation acceleration is within tolerable parameters," but the subtext on his face reads, "We have no idea what's happening." They show thermal maps, trying to argue that shifting sublimation jets could mimic this acceleration. Yet the heat patterns remain static, symmetrical. You shake your head. Symmetry doesn't cause spin, it resists it. A colleague you met once at a conference emails you a screenshot from internal chatter. Could be YORP effect magnified by unusual surface albedo. You reply, "That would require reflectivity near polished metal." She types back one sentence, "Exactly." The room feels suddenly smaller. You remember reading how asteroid 54509 YORP once spun itself nearly to disintegration due to sunlight pressure. Photon nudges adding up over centuries, but Atlas is accelerating too fast. Far faster than mere light could push. Unless, of course, something on its surface is amplifying that pressure, focusing it, maybe through those crystalline layers you already obsessed over. You open your notebook, flip back to the sketch of those smooth glass patches. You draw arrows around them, imagining solar rays bouncing in complex geometry. Maybe they act like mirrors channeling thrust. Still, that wouldn't explain the rhythm. The 10-minute pulse persists in every dataset: brightness, magnetism, now rotation. The cosmos has developed a heartbeat and refuses to go arrhythmic. In the livestream chat, one viewer asks if the comet might be hollow. The ESA spokesperson ignores the question, moving on to slide 9. You scribble the idea anyway. Hollow shell, internal mass redistribution. Then you glance at your window reflection and smirk. I sound like every late-night alien podcast ever. You need perspective, so you dig through old case studies. Comet Holmes, 2007, spontaneous brightening by a factor of 1,000,000. Comet Borisov, 2019, the first interstellar visitor with a genuine coma, composition unlike any known family. Both broke expectations but obeyed physics. Atlas, meanwhile, seems to tease physics with a playful wink. Historians still argue whether anomalies like these expand science or embarrass it. You figure they do both. Embarrassment is just curiosity wearing blush. Your phone buzzes again. It's your graduate student friend sending a single photo attachment. The image shows magnetometer readings plotted against rotation speed, and your breath catches. The two curves are mirror images, every magnetic surge followed by a rotational spike perfectly synchronized. You type, feedback loop. She answers, maybe, or machine, then deletes the message before you can reply. Machine. The word hangs in the air like static. You laugh nervously, muttering, not that movie again. But your brain refuses to drop it. You picture an interstellar probe disguised as a comet, using sublimation jets and magnetic fields as propulsion. It's ridiculous. It's irresistible. You try grounding yourself with numbers. If Atlas truly spins that fast, centrifugal forces should rip it apart within hours. Yet the latest radar scans show it intact. In fact, its shape appears more symmetrical than before, as though rotation is smoothing it out. The longer it spins, the neater it becomes. You whisper, "You're sculpting yourself." ESA's next report mentions the tail growing thinner, straighter, and oddly luminous. The colour correction graph hints that scattered light now leans toward pure white, a sign of fine dust alignment. Magnetic fields could do that. Everything keeps pointing back to magnetism, but no comet should hold such coherence. To distract yourself, you'll open social media. Predictably, it's chaos. Memes of comet fidget spinner flood your feed. Someone overlays techno beats to the 10-minute rhythm captioned, "Alien DJ confirmed." You laugh until you nearly spill your coffee. Humour, as always, rescues sanity. But beneath the noise, serious discussion grows. Independent radio astronomers claim to detect periodic broadband emissions coinciding with Atlas's pulses. They're faint near the threshold of background cosmic hiss, but distinct. ESA denies intentional monitoring of that frequency, which of course convinces everyone it's real. You tune an old shortwave receiver half as a joke, half as a wish. Between static bursts you imagine a faint click, repeating, slow, methodical. You know it's just interference, but still your hand freezes on the dial. You smile nervously, whispering, "All right, if you're out there, blink once for yes." The night stretches long and thin. You review orbital predictions. In 6 weeks, Atlas will make its closest solar pass before slingshotting outward forever. If it holds together, we'll never see it again. If it breaks apart, Earth might inherit fragments decades later. Either way, this is a one-time performance. You think of all the other celestial visitors that came and went. Halley's Comet, Shoemaker-Levy, the Tunguska Mystery. Every age gets the comet it deserves. Maybe ours gets one that spins faster every day, humming with magnetic rhythm, half machine, half myth. Historians in the future will likely reduce it to a line in textbooks. Anomalous rotational acceleration observed, cause undetermined. But you'll remember the feeling, the quiet dread disguised as awe, the absurd laughter at 3 a.m, the realization that knowledge often arrives wrapped in impossibility. Outside, the city lights flicker under distant thunderclouds. You imagine the comet turning in darkness, faster, smoother, its 10-minute pulse echoing like a heartbeat through vacuum. You close your eyes and picture the solar wind catching on its mirrored skin, whispering secrets only the void could understand. For now, all you can do is watch, record, and surrender to wonder. Because when the universe starts dancing faster, you either keep up or let it spin you dizzy. You wake to the thin buzz of your phone vibrating across the desk, the kind of sound that always announces bad news wrapped in neutral language. ESA's latest bulletin headline is deceptively calm. Spin stabilization achieved, 3i, Atlas rotation nominal. You read the words twice, frown, then laugh softly. Nominal, you whisper. That's bureaucratic, for we gave up explaining it. You open the attached telemetry file anyway. The new data shows the comet's spin has suddenly plateaued, holding steady at exactly 3.99 hours per rotation. Not 4. 3.99. The precision is unnerving. Random forces don't stop that neatly. You glance at your fan, whirring in lazy imperfection, and mutter, "Even machines wobble more honestly than this." ESA's analysts appear on stream a few hours later, smiling like diplomats after a near crisis. They call the event dynamic equilibrium. You take a sip of tea gone cold and reply to the screen, "Sure, let's pretend physics found religion." Their slideshow reveals smoother light curves, fewer thermal spikes, and tail emissions now perfectly linear. Whatever was twisting Atlas apart seems to have changed its mind, but you can't stop thinking about the number. 399. It feels deliberate, almost symbolic, like a cosmic in-joke. The 10-minute pulse persists too, hidden in the magnetic data. It's like the comet has reached a comfortable rhythm, fast enough to stay alive, slow enough to stay mysterious. As you scroll deeper, something else catches your eye. The nucleus brightness has increased by not enough for the naked eye, but measurable. And the spectrum, whiter than ever, nearly flat, as if reflecting all wavelengths equally. That's not a comet. That's a mirror pretending to be one. You message your graduate student friend. "Did they tweak calibration again?" She replies instantly, "No, the thing leveled itself out, field lines stabilized." Then after a pause, "It's quiet now, and a quiet." The word unsettles you. The comet that refused to behave is suddenly serene, like a storm deciding to nap. You picture it spinning through the dark, cold, and self-contained, no longer shedding dust, just gleaming. ESA's official tone borders on self-congratulation. "We may be witnessing the natural damping of rotational torque," one scientist says. "A remarkable stabilization mechanism." You hear the applause that follows, polite and relieved, but the relief sounds premature, like clapping at the wrong part of a concert. You close the stream and dive back into the unfiltered telemetry. Beneath the smoothed graphs lies raw chaos, a small oscillation, faint but precise, repeating every 10 minutes and 20 seconds. Not noise, not drift. A whisper still hiding in the spin. You imagine it as breathing under layers of data, steady and patient. To make sense of it, you plot the pulse timing against the comet's orbit. The intervals line up with its distance from the Sun, each pulse lengthening slightly as Atlas drifts inward. The effect mirrors gravitational resonance, but there's no partner to resonate with. It's as if the comet is sinking to something invisible, something far beyond the solar system. You stand, stretch, feel the ache of too many sleepless nights. Through your window, the morning sky glows overcast, metallic, indifferent. You wonder how many people on Earth are awake right now, unaware that an interstellar visitor is spinning in perfect rhythm beyond Mars. Most probably, and maybe that's better. Humanity doesn't handle precision well. It prefers a bit of chaos to keep things believable. You remember Halley's Comet again, the one ancient civilizations feared, then adored, then ignored. Historians still argue whether the awe it inspired drove progress or paralyzed imagination. You suspect both. Every age projects its mood onto the sky. Maybe Atlas just mirrors ours. Half science, half anxiety, endlessly spinning between the two. The feed refreshes with new radar imagery. The shape looks smoother, rounder, as if centrifugal forces have polished it into an ellipsoid. The tail now arcs gracefully, almost symmetrical. You stare at the rendering, half expecting it to blink. "You've gone minimalist," you whisper. "Very Bauhaus of you." Public enthusiasm, meanwhile, is fading. Social media has already moved on, to exoplanet weather patterns, to Martian dust devils shaped like hearts. The great turquoise visitor has become yesterday's algorithm. You scroll past the hashtags and find only a few diehards still posting telemetry overlays and grainy gifs of its earlier fragments. You feel oddly protective, like watching the last ember of wonder dim beneath distraction's snow. Then, late in the day, a single update slips through the ESA channel. No headline, just a quiet technical note: spectral emissions between 475 and 480 mounts reappearing. That's the turquoise line. You sit up so fast your chair creaks. The colour is back, faint but stubborn, a ghost of its former brilliance. The official explanation? Residual calibration anomaly. You laugh, of course it is, but the coincidence gnaws at you. Stabilisation achieved, colour returns, pulse persists. 3 notes of the same melody. You spend the evening watching the comet's simulated orbit on repeat, zooming in and out until the stars blur. Each revolution feels hypnotic, like a pendulum whispering secrets through light. Somewhere between exhaustion and fascination, you catch yourself murmuring, "You're not a comet, are you?" The rational part of your mind protests. Everything fits within physics if you stretch the definitions far enough. Yet, deep down, you sense that Atlas isn't disobeying science. It's teaching it new choreography. Maybe the universe has phases of elegance we haven't charted yet. You dim your monitor, letting darkness reclaim the room. The fan hums in steady rhythm. 4 rotations per second. Nowhere near 3.99 hours, but close enough to remind you that everything spins to survive. For the first time in weeks, your exhaustion feels soft instead of sharp. You close your eyes and imagine floating beside the comet, feeling the slow gravity of its spin, watching the turquoise shimmer bloom faintly at its poles. The silence there would be absolute, yet not empty, filled with the gentle tension between knowing and wondering. If you listened closely enough, maybe you'd hear it. Not a voice, not a signal, just the quiet mechanical sigh of balance found after chaos. You spend the next several days floating in that strange calm ESA calls nominal. It feels like watching the final act of a play where the actors freeze in place but the background keeps moving. The comet has stopped spinning faster, yes, but now the story behind the scenes begins to shift towards something far more human. The question of memory. ESA's analysts start using a new phrase in their updates: archival consistency review. At first it sounds harmless, bureaucratic even, till you realise it means they're pruning data. Files disappear, then reappear with altered metadata, dates drift, timestamps disagree. In one version of the dataset, the turquoise emission vanished for 12 hours. In another, it never existed. You open your folders, compare your saved copies, and feel your stomach tighten. The history of 3i Atlas is being rewritten in real time. You send an email to your contact at the agency. Why are the public logs being edited? The reply is short, weary, and carefully phrased. Standard archival harmonization. We can't preserve every glitch. You stare at the words harmonization and glitch until they start to sound identical. Later that night, you find a private forum thread where other data archivists quietly vent their frustration. One writes, "We're told to remove duplicates, but the duplicates don't match." Another posts an old version of a brightness curve, one that includes the 10-minute magnetic pulse ESA now claims was software noise. The post disappears within an hour. It dawns on you that future researchers may never see the raw weirdness you've been living with. The record will become clean, linear, respectable, and for a moment you feel genuine grief, not for the comet itself, but for the version of history being erased before it's even written. You remember how early astronomers once lost entire centuries of data to wars, fires, and clerical corrections. Halley's observations overwritten by calendar reform, Chinese comet logs translated into nonsense by European missionaries. Historians still argue whether we lost more knowledge to ignorance or to tidiness. You mutter, probably both. The next ESA press release arrives with unsettling politeness. Historical data reconciliation complete. The turquoise anomaly is officially gone, relabeled as an instrument crosstalk artifact. The rhythm in the magnetometer? Telemetry harmonics, the synchronized fragments, dust shadows. It's also neat you could frame it. You sit in front of the screen scrolling through the sterilized timeline. What was once alive with chaos now reads like a physics textbook. Smooth, predictable, bloodless. The comet's light curve shows no heartbeat, no defiance. You almost admire the craftsmanship of the revision, but you still have your local copies, and those, thankfully, tell a different story. You open them one by one, the missing turquoise frame, the pulsing magnetic line, the faint shadow trailing behind the nucleus. You think of them as fossils from a timeline that's already extinct. Out of morbid curiosity, you overlay the revised data with your originals. The differences pulse like hidden veins, faint, stubborn, undeniable. It's as if the comet is still fighting erasure through your computer. You whisper, "You're still here." A strange calm follows. You realise that even if the official record forgets, human memory won't. We are terrible at accuracy but excellent at myth. Someone will always retell this story in whispers and half-truths. The comet that glowed the wrong colour, spun too fast and sang in magnetism. You imagine future historians digging through ESA archives and stumbling on a mismatched checksum, a timestamp that doesn't belong. Maybe one of them will feel the same shiver you felt the first time you saw that turquoise light. Maybe that's enough immortality for any discovery, to linger as a glitch that refuses to reconcile. Still, you feel compelled to preserve your evidence properly. You back up the data onto 3 drives, store them in separate places, one on your local system, one in encrypted cloud storage, one copied onto an old external disk labelled Recipes for Plausible Deniability. You even print the raw graphs on paper, because history has a bad habit of erasing electrons. When you finally look up from your keyboard, the room has gone dark except for the soft reflection of the comet's trajectory animation looping endlessly. You watch the line sweep across your screen, its path extending beyond the orbit of Jupiter, then outwards toward the invisible border of the solar system. It strikes you how temporary everything here is. Servers, agencies, even curiosity itself. Atlas will outlast all of it, gliding into the long dark with its secrets intact. The data wars, the sanitized reports, your late-night paranoia, all of it will fade like the echo of a broadcast that no one tuned in to hear. Still, you can't shake one small, irrational comfort, that somewhere in the deep future, another civilization, human or not, might intercept this comet and wonder why its magnetic field pulses every 10 minutes. Maybe they'll argue about it too. Maybe they'll file it under anomalies. Maybe they'll smile and say someone must have noticed. You lean back, exhale slowly, and let the glow of your monitor soften. The fan hums its steady rhythm beside you, the only pulse that hasn't been edited away. Outside, the city sleeps under its man-made constellations, streetlights and aircraft, signals and ghosts. Above them all, 3i Atlas spins quietly, still writing history in a language you're not sure anyone is supposed to read. You whisper, "Don't worry, I remember." It's a week later when you realise the conversation around 3i Atlas has shifted from cautious curiosity to collective speculation. The headlines no longer belong to ESA, they belong to talk shows, fringe science podcasts, and the endless carnival of online think pieces. The phrase fringe theories, serious faces trends for 2 straight days. You scroll through thumbnail after thumbnail of people gesturing at star maps, eyes wide with revelation. Somewhere between laughter and second-hand embarrassment, you wonder how long it takes for wonder to become conspiracy. On one stream, a former astronaut speaks with the measured patience of someone trying to herd cats. "Look," he says, "the data's weird, yes, but weird doesn't mean alien." The host nods gravely, already queuing up a slide titled The Interstellar Probe Theory. You sigh. The algorithm loves drama, and Atlas has become its favourite soap opera. Still, you can't entirely dismiss them, because beneath the clickbait and the memes lies an odd pattern. Every fringe claim echoes something you've actually seen in the data. The magnetic pulses, the symmetry, the erased files. Each sensational theory feels like a funhouse mirror version of your quiet notes. You mutter, "They're wrong for all the right reasons." One theory suggests the comet is a seed craft, a self-replicating probe wrapped in organic ice, camouflaged as debris. Another claims the turquoise emissions was a communication attempt, photons modulated across unknown frequencies. You almost choke on your tea at that one. If it was communication, you say to no one, the first message was probably, "Stop staring." Yet the strangest rumour of all comes from an academic conference panel, legitimate credentials, expensive suits, serious tone. A planetary scientist leans toward the microphone and says, "We can't rule out that some of the observed phenomena are artificial in origin." The room goes still. It's the exact phrase that detonated the Oumuamua controversy years ago, back when the world wasn't tired enough to ignore wonder. Historians will someday debate whether that moment, the cautious admission from a serious face, marked the point when science learned to flirt openly with imagination again. You think of Newton's alchemy, Kepler's angelic orbits, Galileo sketching the moon as if it were divine architecture. Maybe every few centuries, rationality gets lonely and calls imagination back for coffee. Still, ESA pushes back. A stern press release declares, "No evidence supports claims of artificial structure or intent." The sentence is so perfectly balanced it almost winks. You save a screenshot anyway because bureaucratic poetry ages better than truth. The chatter only grows louder. A late-night radio host claims to have intercepted rhythmic radio noise at the comet's pulse frequency. It's almost certainly Earth-based interference, but his voice trembles with conviction. "If they're out there," he says, "they've been watching us longer than we've been watching them." You whisper, maybe they're just bored. Even serious institutions join the dance. A European think tank publishes a paper titled "The Socio-Philosophical Implications of Non-Natural Interstellar Visitors." It reads like a cross between philosophy and fan fiction, quoting everything from Sagan to Shakespeare. One line sticks with you: "To deny the extraordinary is to confess our fear of explanation." You underline it twice in your notes. The irony, of course, is that no one actually knows what's happening anymore. The data is too clean, too edited. The official record now describes a calm, stable comet coasting toward the sun, perfectly ordinary except for a few unverified irregularities. Yet the rumour ecosystem thrives on those irregularities, feeding them like embers into new myths. You scroll through a thread of amateur astronomers trying to photograph the comet. Most fail. One succeeds. A long exposure from the Canary Islands shows a faint turquoise smear, real or imagined. The comments erupt. Confirmed colour return. ESA can't hide it. You laugh softly. It's chaos, but it's honest chaos. Then your inbox pings again. Your graduate student contact sends you a cryptic message. "Conference tomorrow, they'll show something." You reply instantly. What's something? No answer. The next 24 hours feel longer than an orbit. The live feed from the ESA auditorium begins with sterile enthusiasm. Slides of the comet's trajectory, chemical of the data, spin rate, all routine. Then the lights dim and a new image appears, a radar echo map from the agency's deep space antenna network. You lean forward, breath caught in your throat. The radar returns show something denser than expected near the nucleus, a core with sharp geometric boundaries, triangular symmetry. The room on screen falls silent. The presenter clears his throat and calls it a data processing artifact. You nearly laugh out loud. "Of course it is," you whisper, echoing every scientist's favourite spell against discomfort, but you freeze the frame on your second monitor. The shape is too regular, too aligned with the comet's rotation axis. If it's an artifact, it's the most artistic artifact in ESA history. You take a screenshot and save it beside your turquoise frames. You name the file artifact in quotes "ne." After the presentation, social media predictably combusts. Memes of pyramid-shaped comets flood the web. Someone edits a clip of the radar image into a 1980s sci-fi intro with synth music. You almost appreciate the absurdity. Humanity meets cosmic mystery and responds with graphic design. Still, something gnaws at you. The presenter's hands, when he gestured to the radar image, trembled slightly. Not fear exactly, more like the tremor of someone holding back excitement. Maybe deep down, they all feel it too, the whisper that this story refuses tidy endings. You step outside, craving real starlight instead of pixelated approximations. The city hums beneath a thin fog. Above, the night sky glimmers faintly, unedited. Somewhere out there, 3i Atlas spins, carrying either geometry or coincidence, truth or artifact, reflection or intent. You inhale the cold air and feel it fill your chest like clarity. For the first time in weeks, you accept that maybe it doesn't matter whether it's alive, mechanical, or simply beautiful. The point is that it made you, and thousands of others, look up again. Wonder survived the algorithm for a moment. That's something. You whisper to the invisible comet, "Whatever you are, thanks for reminding us." By now, the name 3i Atlas has escaped the domain of science altogether and slipped into pop culture like a viral dream. There are documentaries with ominous soundtracks, novels rushed into print with titles like The Visitor That Wasn't, and even a perfume ad that uses a slow-motion rendering of the turquoise tail as backdrop for whispered promises about infinity. You shake your head and mutter, "It's official. The universe can't throw a snowball without getting a brand deal." Yet beneath the noise, something genuinely new surfaces. A quieter, more serious hum coming from inside ESA itself. A small note in their daily log mentions localized magnetic murmurs detected, ongoing assessment. You open the supplementary file expecting numerical dullness. Instead, you find a column labelled UT variance. Its graph pulsing like a heartbeat across the page. Every spike is evenly spaced. 10 minutes again, you can't help laughing. You just refuse to improvise, don't you? But this time, the pattern isn't mere background chatter. The amplitudes have tripled since the previous observation window. The magnetic field surrounding Atlas is strengthening. ESA's internal memo calls it flux density resonance. They speculate it could be induced by interaction with solar wind particles, charged ions streaming from the sun, meeting the comet's ionized halo. That explanation almost works, except for one stubborn fact. The strength of the field rises and falls ahead of the predicted solar gusts, as if anticipating them. You write the phrase pre-response pattern in your notebook, underlining it twice. At the press briefing, the lead physicist leans into the microphone and says the field appears self-modulating. The audience stirs. Self-modulating is a polite way of saying it adjusts itself. He quickly adds, "We're likely observing complex plasma feedback." You can feel the room wanting to believe him but failing to. The slide behind him displays a colour map of magnetic wavefronts wrapping around the comet like luminous ripples. They look almost musical, notes frozen in vacuum. When the feed ends, you replay the recording at double speed. The pulsing field lines form geometric patterns, concentric circles, then spirals, then something resembling a helix twisting along the comet's axis. You whisper, "That's more organised." It's the sort of elegance nature rarely bothers with unless forced by hidden order. You check independent data from the Solar and Heliospheric Observatory. Their magnetometers show the same pulse, echoing millions of kilometres away, faint but measurable. It's as if Atlas is broadcasting a rhythm that space itself can't ignore. You imagine it as sonar in the void, a beacon calling to nothing and everything. Theories multiply overnight. Plasma physicists propose resonant coupling between cometary ions and interplanetary magnetic fields. Radio engineers wonder if the pattern's harmonic ratios, precisely 2.3/5, could arise naturally. Mathematicians smile faintly and say those ratios appear everywhere from music to molecular geometry. Historians still argue whether humans invented harmony or merely copied it from the cosmos. You grin. Tonight, the cosmos seems to be returning the compliment. ESA's next bulletin tries to sound unruffled. Field fluctuations pose no operational concern, but you notice the data cadence has doubled. They're recording twice as often now, which means they're worried. In the chat, someone jokes that the comet is learning to play jazz. Another posts a gif of a metronome syncing to a drumbeat titled, "Atlas drops a new track." You laugh, though unease flickers behind the amusement. Because if this field keeps amplifying, the comet could start interacting with the solar wind in unpredictable ways. Tail realignment, plasma discharge, even spontaneous electrical arcing. You remember the 1989 event when Comet Halley's plasma tail briefly connected with Earth's magnetosphere, causing auroras in places that had never seen them before. Historians still argue whether that phenomenon was coincidence or electromagnetic luck. You wonder what would happen if Atlas pulled the same stunt, only stronger. Late that evening, you tune a small receiver to the frequencies where the magnetic oscillations convert into audible hum. Through static, you catch a faint thrumming, slow, deliberate, hypnotic. Every pulse lasts about 10 seconds, each followed by a whispering hiss like wind through wires. You close your eyes and listen, letting the sound crawl under your skin. It feels almost biological, like a heart slowed by eons. Your phone vibrates. A message from your grad student friend. Field intensity exceeded predicted maxima by 240%. They've stopped calling it noise. You text back, "So what now?" she replies. Now they measure again and again until they can rename it something safe. Outside, thunder grumbles above the city. You step to the window, imagining the comet far beyond the clouds, its magnetic shell expanding like a slow explosion of invisible colour. Lightning flashes, and for a moment the sky looks turquoise. You blink, unsure whether it's imagination or reflection. You remember an old Greek myth about the lyre of Orpheus, how its music could move stones and trees. You chuckle softly. Maybe you're just tuning spate and you tell the unseen comet, a galactic lyre strumming the void. The next morning, ESA announces they'll conduct coordinated observations with multiple deep space probes. Cross-validation, they call it. You know the real reason. They want witnesses. The field's amplitude has become impossible to ignore. A faint electromagnetic storm now travels ahead of the comet, an invisible wake that sensors detect long before the object itself passes. The phrase magnetic murmurs no longer feels poetic. It feels literal, as if space is whispering secrets through frequency. As night falls, you switch off your monitor, letting the hum of your fan mimic that same slow rhythm. For the first time, you sense that the comet might be less an object and more an event, an ongoing conversation between forces you barely understand. Whether it's speaking, singing, or simply existing loudly doesn't matter. What matters is that you're listening. And perhaps that's all the universe ever wanted, to be heard. You wake to a storm outside and an inbox flooded with messages, each one tagged urgent. The subject line that matters most reads, "The problem with the photos. Your graduate student contact has attached a compressed folder. No explanation, just a nervous emoji." You unzip it and find side-by-side comparisons of ESA's official images and the originals pulled from the telemetry stream. The differences hit you like cold air. Pixel clusters erased, tails shortened, shadows straightened, and most alarming, black rectangles floating where data should be. You lean close to the screen. The masking isn't random, it follows a grid, a deliberate algorithm. Each removed patch sits at an interval matching the 10-minute pulse. You whisper, "So you edited time, not space." The thought makes your skin tighten. Someone hasn't just brightened a photo, they've sculpted a rhythm out of visibility. A new message arrives from her. They're testing image-to-noise filters, officially. You reply, "And unofficially?" After a long pause comes, "Someone said contain pattern recognition artifacts. I don't know what that means." You laugh without humour. It means they saw something they didn't want software to learn from. You drag one of the raw frames into your editing program and crank up the exposure. At first you see nothing, just the comet's halo, faint dust, and digital static. Then slowly, shapes emerge in the background noise, arcs repeating like ribs, geometric shadows arranged in concentric loops. You check metadata. The image was captured exactly during the strongest magnetic surge. You whisper, "It's in sync." You remember how early lunar photos were airbrushed to remove lens artifacts that turned out to be boulders. Historians still argue whether that was censorship or caution. You grin. History might be writing the same paragraph again, only this time in pixels instead of paint. Scrolling through the sequence, you notice a subtle flicker at the same coordinates across frames. It's not moving relative to the stars, it's moving relative to the camera, as if compensating for motion, a self-correcting blur. You imagine an object reflecting light selectively, hiding whenever the exposure peaks. The idea is absurd, but so is everything else about Atlas. ESA's daily update lands on the feed at noon. The headline is soothingly dull, imagery compression adjustments completed. The accompanying video claims that slight mismatches created the illusion of structured shadows. You chuckle. Illusion is science's polite word for embarrassment. The comments section explodes anyway. People freeze-ins, draw circles, demand transparency. ESA disables replies within the hour. You spend the afternoon assembling your own timeline of the deletions. The first masked frame appeared the day the turquoise light returned. Every subsequent adjustment aligns perfectly with the magnetic pulses. It's as if the photographs were edited in rhythm, beat for beat. You start tapping your pen in time. 10 minutes, the now familiar tempo of unease. To clear your head, you step outside. The city is wet and glimmering, reflections sliding along puddles like mirrored data. You catch your own face distorted in a streetlight's reflection, sliced by rain. Maybe that's all these photos are, you think, reflections arguing with themselves. Back at your desk, you notice something eerie. The blanked rectangles in the images form a lattice if you overlay them sequentially. It looks like a map, rows and columns intersecting at precise coordinates. You overlay the comet's rotation model and almost drop your mug. The grid aligns with the thermal nodes on the surface, those glass patches you studied earlier. Someone or something is editing along physical boundaries, not random pixels. You whisper, "Why censor symmetry?" The next ESA conference begins with visible strain. The communications director looks straight into the camera and declares, "All imagery is authentic, no digital alteration beyond standard calibration." The words hang brittle in the air. You've seen that tone before, on historians denying forgery, on politicians rehearsing certainty. Then a reporter asks whether the dark bands in the latest photos correspond to the magnetic coordinates. The feed cuts briefly, resumes with a different angle, question forgotten. You replay the silence, slower. For half a second before the feed switches, you glimpse one of the scientists in the background shaking his head and mouthing a single word, a stop. You exhale through a shaky laugh, so they do know. Outside the community of professionals, the internet spirals. Forums overflow with pixels detectives, each convinced they've found hidden structures, grids, letters, even faces. You can't decide what's more unnerving, that most are wrong or that a few might not be. You upload one of your raw frames to an open source image analysis AI, just to test the pattern recognition artifact excuse. The program highlights a region near the comet's nucleus and labels it linear array high regularity. You run it again on a control photo from another comet. The AI finds nothing. You whisper, "So it wasn't hallucinating." You remember an anecdote from the early days of digital imaging. When the first Mars orbiter returned pictures of dunes, an overzealous technician accidentally smoothed them so perfectly that they looked artificial. Decades later, historians still debate whether that one aesthetic correction delayed recognition of true geological patterns. You grin grimly. History's repeating itself, only this time the smoothing hides something that might not want to be seen. As midnight approaches, your monitor hums with the heat of overuse. You stare at the final composite you've built. 15 layers of edited and unedited frames, each one slightly misaligned. When viewed in rapid sequence, the masked regions pulse like a strobe. You lean closer, heart hammering. The rhythm matches the magnetic cycle perfectly. The comet is editing itself into your software, erasing and revealing on cue. For the first time, you pull back from the screen, genuinely uneasy. Maybe the agency isn't hiding anything sinister. Maybe they're just terrified. Because if the pattern is intrinsic, if Atlas is producing structured interference on purpose, then every photograph is a conversation between machine and phenomenon, neither fully in control. You close your laptop and sit in darkness, listening to rain. The pattern is gone, but your heartbeat won't slow. You whisper to the empty room, "All right, Atlas, message received." Outside, thunder rolls again, and somewhere beyond the clouds, a turquoise ghost spins through vacuum, perfecting its own form of privacy. You wake to a storm outside and an inbox flooded with messages, each one tagged urgent. The subject line that matters most reads, "The problem with the photos." Your graduate student contact has attached a compressed folder. No explanation, just a nervous emoji. You unzip it and find side-by-side comparisons of ESA's official images and the originals pulled from the telemetry stream. The differences hit you like cold air. Pixel clusters erased, tails shortened, shadows straightened, and, most alarming, black rectangles floating where data should be. You lean close to the screen. The masking isn't random, it follows a grid, a deliberate algorithm. Each removed patch sits at an interval matching the 10-minute pulse. You whisper, "So you edited time, not space." The thought makes your skin tighten. Someone hasn't just brightened a photo, they've sculpted a rhythm out of visibility. A new message arrives from her. They're testing image denoise filters. Officially. You reply, "And unofficially?" After a long pause comes, "Someone said contain pattern recognition artifacts. I don't know what that means." You laugh without humour. It means they saw something they didn't want software to learn from. You drag one of the raw frames into your editing program and crank up the exposure. At first you see nothing, just the comet's halo, faint dust and digital static. Then slowly shapes emerge in the background noise, arcs repeating like ribs, geometric shadows arranged in concentric loops. You check metadata. The image was captured exactly during the strongest magnetic surge. You whisper, "It's in sync." You remember how early lunar photos were airbrushed to remove lens artifacts that turned out to be boulders. Historians still argue whether that was censorship or caution. You grin. History might be writing the same paragraph again, only this time in pixels instead of paint. Scrolling through the sequence, you notice a subtle flicker at the same coordinates across frames. It's not moving relative to the stars, it's moving relative to the camera, as if compensating for motion, a self-correcting blur. You imagine an object reflecting light selectively, hiding whenever the exposure peaks. The idea is absurd, but so is everything else about Atlas. ESA's daily update lands on the feed at noon. The headline is soothingly dull, imagery compression adjustments completed. The accompanying video claims that slight mismatches created the illusion of structured shadows. You chuckle. Illusion is science's polite word for embarrassment. The comments section explodes anyway. People freeze frames, draw circles, demand transparency. ESA disables replies within the hour. You spend the afternoon assembling your own timeline of the deletions. The first masked frame appeared the day the turquoise light returned. Every subsequent adjustment aligns perfectly with the magnetic pulses. It's as if the photographs were edited in rhythm beat for beat. You start tapping your pen in time, 10 minutes, the now familiar tempo of unease. To clear your head, you step outside. The city is wet and glimmering. Reflections sliding along puddles like mirrored data. You catch your own face distorted in a streetlight's reflection, sliced by rain. Maybe that's all these photos are, you think, reflections arguing with themselves. Back at your desk, you notice something eerie. The blanked rectangles in the images form a lattice if you overlay them sequentially. It looks like a map, rows and columns intersecting at precise coordinates. You overlay the comet's rotation model and almost drop your mug. The grid aligns with the thermal nodes on the surface, those glass patches you studied earlier. Someone or something is editing along physical boundaries, not random pixels. You whisper, "Why censor symmetry?" The next ESA conference begins with visible strain. The communications director looks straight into the camera and declares, "All imagery is authentic, no digital alteration beyond standard calibration." The words hang brittle in the air. You've seen that tone before, on historians denying forgery, on politicians rehearsing certainty. Then a reporter asks whether the dark bands in the latest photos correspond to the magnetic coordinates. The feed cuts briefly, resumes with a different angle, question forgotten. You replay the silence, slower. For half a second before the feed switches, you glimpse one of the scientists in the background shaking his head and mouthing a single word. "Stop!" You exhale through a shaky laugh. So they do know. Outside the community of professionals, the internet spirals. Forums overflow with pixel detectives, each convinced they've found hidden structures, grids, letters, even faces. You can't decide what's more unnerving, that most are wrong or that a few might not be. You upload one of your raw frames to an open source image analysis AI just to test the pattern recognition artifact excuse. The program highlights a region near the comet's nucleus and labels it linear array, high regularity. You run it again on a control photo from another comet. The AI finds nothing. You whisper, "So it wasn't hallucinating." You remember an anecdote from the early days of digital imaging. When the first Mars orbiter returned pictures of dunes, an overzealous technician accidentally smoothed them so perfectly that they looked artificial. Decades later, historians still debate whether that one aesthetic correction delayed recognition of true geological patterns. You grin grimly. History's repeating itself. Only this time the smoothing hides something that might not want to be seen. As midnight approaches, your monitor hums with the heat of overuse. You stare at the final composite you've built. 15 layers of edited and unedited frames, each one slightly misaligned. When viewed in rapid sequence, the masked regions pulse like a strobe. You lean closer, heart hammering. The rhythm matches the magnetic cycle perfectly. The comet is editing itself into your software, erasing and revealing on cue. For the first time, you pull back from the screen genuinely uneasy. Maybe the agency isn't hiding anything sinister. Maybe they're just terrified. Because if the pattern is intrinsic, if Atlas is producing structured interference on purpose, then every photograph is a conversation between machine and phenomenon, neither fully in control. You close your laptop and sit in darkness, listening to rain. The pattern is gone, but your heartbeat won't slow. You whisper to the empty room, "All right, Atlas. Message received." Outside, thunder rolls again, And somewhere beyond the clouds, a turquoise ghost spins through vacuum, perfecting its own form of privacy. By the next sunrise, the entire planet has an opinion. The 3i Atlas hashtag glows in every language, every time zone bouncing between disbelief and rapture. ESA has released a new statement. 3 polite paragraphs beginning with, "We understand public interest," and ending with the immortal bureaucratic lullaby, "No cause for alarm." You scroll past it to the attached graphs and see what they don't say. The comet's magnetic field has surged again, 4 times stronger than the week before. Your phone vibrates with news alerts. Public panic, private calm. That's the tone everywhere. A London tabloid screams about the alien dynamo. A tech site blames a miscalibrated instrument and calls it a software hiccup trending on humanity's fear of mystery. Somewhere between those extremes lies the truth, humming quietly in the data that hasn't yet been deleted. You turn on the ESA stream out of habit. The director looks pale but steady. "All spacecraft telemetry remains within operational parameters," he says, eyes darting off screen. "Our magnetometers have entered protective standby mode as a precaution." You whisper, "Translation. We turned off the sensors before they contradicted us again." Social feeds become surreal. Someone launches a 24-hour live stream of a blue LED pulsing every 10 minutes, syncing with the comet's unseen heartbeat. Millions tune in. Another group forms an online meditation circle claiming they can feel the pulses in their bodies. You scroll, half horrified, half enchanted. The world has turned data into ritual. Meanwhile, ESA's servers strain under traffic. Downloads of raw images are throttled, archives intermittently unavailable. Yet within minutes, copies bloom across mirror sites like dandelions. You watch the democratization of curiosity unfold in real time, humanity refusing to let wonder be centralized. The mainstream news attempts composure. Anchors smile thinly while saying words like plasma oscillation and magnetic interference. Their voices tremble at the edges. You catch snippets of genuine awe between the lines, as if even the teleprompter wants to know what Atlas is doing. Then comes the silence. For 12 straight hours, no new data appears. ESA cites solar interference. The internet explodes with speculation. The comet's field collapsed. The instruments failed, contact lost. You refresh every 5 minutes until finally a new bulletin appears. It's only 1 sentence long. Field amplitude stabilized at 1.2 microtesla. That's higher than anything recorded from a comet before. You exhale a shaky laugh. Stabilized, you repeat. Sure. You plot the readings yourself and notice a subtle modulation in frequency, like a tremor beneath the surface. It's not random, it's encoded. Maybe not deliberately, but still. Information embedded in rhythm. You play the data as audio just to hear it. Out pours a slow oscillating hum, rich, layered, eerily melodic. You imagine the entire solar system vibrating faintly to that tone, planets resonating like distant tuning forks. The rational part of your brain insists it's coincidence. The rest of you just listens. Historians will probably compare this week to 1938's War of the Worlds broadcast, fear and fascination bleeding together. You chuckle at the thought, the same primal thrill, only now the static comes from space instead of radio. Historians still argue whether Orson Welles wanted panic or poetry, maybe both. You take a walk to clear your head. Outside, every screen in the cafe window glows with that same turquoise tail looping behind presenters and pundits. The comet has become a celebrity. Its magnetic field, the world's newest influencer. Teenagers remix its pulse into music. Artists paint it across murals. Preachers quote it as proof of divinity. You overhear someone say, "It's the universe reminding us we're not alone." You smile, half agreement, half fatigue. Back home, you check your inbox again. Another message from your friend. Internal briefing today. They're calling it self-regulating magnetism now. Don't ace. You type back, "Too late," she replies. "Off record. The field lines are forming nested spirals. That shouldn't happen without direction." You stare at those words until they blur. Nested spirals, like fingerprints. You open the latest visualizations and there they are. Elegant and deliberate, swirling around the comet's axis. You trace them with your finger across the screen. "That's choreography," you whisper. Outside, thunder rolls again, distant and restless. The fan on your desk hums, sinking unconsciously to the rhythm you've memorized. 10 minutes, one beat. The pattern has invaded everything, the clock you're breathing, the pulse in your neck. You think back to every phrase ESA has used to soothe the public, nominal, harmonic, stabilized. Words designed to tuck anomaly under a blanket. But you've learned that calm tone hides the loudest discoveries. As the storm outside breaks open, lightning flickers against your window pane. For an instant, the reflection on the glass turns turquoise. It's just city light refracted through rain, but the coincidence makes you laugh out loud. You win again, you tell the comet. Later that night, ESA finally releases a new image, a wide-angle shot from their deep space probe, showing the comet's tail stretching farther than ever, luminous and impossibly straight. It's breathtaking, but your eyes go to the margins where faint interference lines run diagonally through the black. The caption claims sensor crosstalk, but you already know that tune. You lean back, exhausted, grinning despite yourself. Whether machine or miracle, comet or communication, 3 Arthe Atlas has forced a planet to look up, listen, and argue again. Maybe that's all it ever wanted. It happens quietly, without countdown or fanfare. One final update buried at the bottom of ESA's morning feed. Comet 3I Atlas, now departing the inner solar system. Just like that, the visitor begins to leave, drifting outward on a path that curves through the black like a signature being withdrawn. You stare at the line on your monitor, the faint blue trajectory stretching toward infinity, and realize how quickly a phenomenon becomes a memory. They release one last photo set, the farewell sequence. The images show the comet as a pale ember against the dark, its turquoise sheen muted to faint silver. The tail extends for millions of kilometers, thinning into transparency, a whisper of dust dissolving in sunlight. The caption reads, "Residual magnetic activity persists." You chuckle. Even in departure, Atlas refuses to be normal. The numbers tell a calmer story now, spin constant, field diminishing, radiation scattering. Everything appears to be winding down, as if the universe itself is exhaling. Yet you don't trust stillness anymore. You've seen too many anomalies bloom inside it. The ESA spokesperson thanks the public for their engagement and assures everyone that no artificial signatures remain unaccounted for. It's the neat, diplomatic ending you knew was coming, a story restored to order. But as the live stream ends, you catch a flash of genuine emotion on the analyst's face. That haunted satisfaction of someone who has witnessed something extraordinary and promised never to say so aloud. You open your private folders, scanning through every file you've hoarded. The corrupted turquoise frames, the masked grids, the audio hums, the notes about rhythmic magnetism. Each one feels like a fragment of a fading dream. You wonder if you've been cataloguing evidence or poetry, maybe both. As the comet coasts farther away, light delay grows. Each new frame you receive is older than the last. Messages from hours ago, then days. Watching Atlas becomes like watching memory itself. Always late, always echoing, you whisper, "Goodbye, a time traveller," and feel foolish but sincere. The world predictably moves on. News cycles pivot to the next curiosity. A Martian dust storm shaped like a spell, a minor satellite glitch mistaken for an alien broadcast. Atlas slips quietly out of trend. The LED livestream ends, its final pulse looping forever in replay. Yet somewhere beneath the noise, small communities keep the flame alive. Astronomers, artists, late-night philosophers. They call themselves the Watchers. You don't join, but you read their posts with a faint private smile. One evening, you step outside seeking the real sky instead of pixels. The air is crisp, the city quieter than usual. Above, stars scatter like coded messages. You imagine Atlas gliding far beyond Jupiter's orbit now, invisible, carrying its turquoise heart into deeper cold. The thought steadies you. Whatever it was, natural or not, it behaved like everything that passes through existence. It shone, confused, it left. You remember another celestial farewell, the 94 Shoemaker-Levy collision, when Jupiter absorbed a comet and stitched its remains into cloud bands. Historians still argue whether the event was tragedy or spectacle. You think maybe both again. Every departure writes its own version of both. Later that night, you replay the final raw video feed. Frame by frame, the comet shrinking until it's just a pixel. You freeze the last frame, brighten it, enhance it. For a moment, you swear you see the faintest pulse, a single flicker in that dying point of light. It could be compression artifact. It could be goodbye. Your grad student contact sends one final email. Mission officially closed. Data servers archived. We're moving to new projects. Then a second, shorter one follows minutes later. Between us, the magnetometer's still picking up echoes. You don't reply. Some secrets deserve silence. Days pass. Your routine reforms itself around earthly rhythms again. Meals, errands, deadlines. Yet the 10-minute pulse remains lodged in your mind, like a metronome embedded behind your thoughts. Sometimes you catch yourself timing it unconsciously, glancing at the clock as if waiting for an invisible signal. You laugh it off, but the habit persists. One night, half asleep, you dream of floating beside Atlas. In the dream, its surface is smooth as glass, colours rippling beneath like northern lights trapped under ice. The turquoise hue glows brightest at the poles, where magnetic lines weave around you like gentle threads. You reach out and touch one. It hums, a low vibration, neither sound nor light but something in between. The rhythm matches your heartbeat until you can't tell which belongs to which. You wake before dawn, the fan humming, the city silent. On impulse, you turn on your radio receiver and scan the low frequencies. For a moment, there's nothing. Then, so faint you almost doubt it, a soft, periodic whisper. 10 minutes apart. You smile, exhausted and exhilarated. Maybe it's just interference. Maybe it's memory playing tricks. You jot one last note in your journal. Signal persists after departure. Then you close the notebook for good. As sunlight creeps across your desk, you whisper to the fading stars, "Travel well." Somewhere countless kilometers away, the comet that once made a planet argue, laugh and wonder drifts onward, leaving behind nothing but a rhythm. And maybe, just maybe, that's enough proof that we were listening. Weeks slip into months, and the world learns to stop refreshing its sky. The ESA homepage quietly removes 3i Atlas from the Active Mission sidebar, replacing it with new headlines about asteroid mining initiatives and deep space probe launches. You stare at that blank space where the name used to sit and feel an odd sense of vertigo, like stepping off a moving walkway while your brain keeps gliding forward. For nearly a year, the comet dictated your sleep, your curiosity, even your heartbeat. Now it's gone, officially catalogued, archived, sanitized, but the silence it leaves behind doesn't sound like closure, it sounds like an intake of breath. You still check the data stream, of course. Old habits cling like gravity. Every few nights, you scroll through the deep space telemetry, waiting for noise that might not be noise. Occasionally, you catch a faint pulse hidden in the static, 10 minutes apart, persistent as memory. You smile, never sure whether it's real or just the echo of your own obsession bouncing through code. Maybe the difference doesn't matter anymore. The scientific community has moved on. Papers are published, peer-reviewed, neatly footnoted. No evidence of artificial mechanisms, the consensus reads. Unique plasma and albedo phenomena consistent with natural origins. You can almost hear the sigh of relief in every sentence. Academia loves mysteries, but it loves containment more. One footnote even mentions public misinterpretation exacerbated by social media dramatization. You laugh softly. Public misinterpretation, you murmur. That's what they call wonder now. And yet privately, some scientists confess doubts. Over coffee, your graduate student friend, now a full researcher, leans in and whispers, "The models still don't fit. There's an energy deficit we can't explain." You grin. "Energy deficit," you echo. "Sounds like a human problem." She laughs, but there's fatigue in it. "Maybe," she says, "or maybe the data was smarter than us." ESA has already begun the process of sealing the raw archives. The earliest unfiltered frames, the ones with turquoise light and magnetic noise, are marked restricted access. Only approved researchers can download them now, and even then, only for comparative analysis. You're not one of them. You suspect you were never supposed to be. Still, you have your backups. Sometimes you open them late at night, not to analyze but to remember. You play the old video loops, the turquoise flare, the faint hum converted from magnetometer readings. The rhythm still matches your fan, your pulse, the quiet electricity running through the apartment walls. You think maybe that's why it captivated you. Not because it broke physics, but because it mirrored something deeply human. The need to find pattern in noise, the need to listen for heartbeat in vacuum. In those quiet hours, you reread your own notes. Some pages read like data logs, others like diary entries, others like love letters to a question. You stopped trying to categorize them. Atlas blurred those boundaries too. It arrived as a comet, behaved like a riddle, left as a story. What label could survive that kind of orbit? One evening you receive an unexpected parcel, no return address. Just a data drive and a single printed page. On the page a simple line, "Echoes persist beyond heliopause." Your hands tremble as you plug the drive into your computer. Inside a single file, a spectrogram of faint magnetic oscillations, time-stamped weeks after ESA's last contact. The signature looks familiar, spaced evenly, rhythmic, 10 minutes apart. You stare at it until your eyes blur. Beyond the heliopause, outside the sun's influence. Whatever this is, it's still pulsing out there, drifting through interstellar space, unbothered by our disbelief. You whisper, "You kept your beat." The data doesn't reveal directional meaning, only continuity. And somehow that feels perfect. The story was never about explanation, it was about endurance, about the way ideas, like comets, refuse to fade completely. Historians still argue whether the mystery of Atlas advanced science or simply entertained it. You suspect it did both. Every unsolved thing plants a seed. You close the window, step outside and look up. The night sky is vast and indifferent, yet it feels less empty now that you know something, some pulse, some rhythm, is still threading through it. You imagine future generations with better instruments, listening again, finding the same signal and wondering who first heard it. You hope they keep the curiosity intact, not just the data. Wind brushes against your face. It smells faintly of rain and streetlights. You realize how much of your life unfolded under the hum of questions, questions that might never be answered, but always deserve to be asked. You smile, a small gesture offered to the cosmos. "You win," you whisper. "You always do." Back inside, you save one final file, labeling it Atlas, Last Echo. You don't analyze it. You just sit, eyes closed, and let the rhythm play through your speakers, a slow, deliberate pulse beneath the static, steady as a heartbeat. The universe breathing in, breathing out. You remember the very first frame you ever saw, the turquoise glow against infinite black, and feel the same shiver you felt then. Awe hasn't diminished with understanding, it's multiplied. Maybe the problem was never the photos, never the missing data, never the cover-ups. Maybe the problem was that we wanted certainty from something that came only to remind us of mystery. The fan hums beside you, constant as ever, and somewhere out there, a frozen traveller continues its silent journey, its rhythm stitched into the dark between stars. You close your notebook and whisper, "Travel well, and take our questions with you."